Wonderful. Welcome to everyone to the AgMIP team's open house. We've had a wonderful set of team meetings over the past 2 days. And now on today, Thursday, we're having our forum plenary sessions. We had a wonderful session earlier today with over 100 participants. And so we're really, this is our kind of giant report back from the team's meetings over the past 2 days. A wonderful chance to get to really, as Alex was just saying, the real, like the full breadth, the full spectrum of AgMIP activities. John Antle and Alex Ruane are going to help to moderate this session. Which is going to start off. I'm going to give a brief introduction, overview of AgMIP. But first, want to share with you, Eric, can you hop on, if that's easy, and explain this?
Sure, yeah, this is the, so the registrants for the open house, for the full open house. So as Cynthia was saying, we had some sessions yesterday, some team sessions, and then today we had the 2 plenaries. So this is everybody. The registrants broken down by country. So we have just recently passed the 700 mark of registrants, and we have about 97 or so countries. And yeah, so this is also US, India, Pakistan, Germany, and Ethiopia are making the top 5. But we have representatives from all of these countries, which are hard to read because there's so many of them. But yeah, over 95 countries represented.
Wonderful. So this is a silver lining of the terrible coronavirus, that pandemic, that we really have expanded our scope and can welcome so many people, so many modelers from around the world and from so many countries. So this is our overview of where we are with the AgMIP community, and it's 40 plus. We used to say 30 plus, but now we say 40 plus research and application activities. And you see at the bottom, the executive committee is John Antle, Sentilda Singh, Herman Lutzekampen, Anthony Whitbread. Alex Ruane is the overall science coordinator for AgMIP. As you all know, because you're here and are participating in it, AgMIP is a worldwide science community that was founded in 2010. So one of the things is that one of the themes I would say emerging from this week is, well, we're not a new kid on the block, but we are not getting stale in any way. The science is still absolutely cutting edge. The enthusiasm for the work of the teams, we feel is still very, very strong. And we hope at the end of this session, you'll feel that too. But, oh, and by the way, Eric, could you or someone, or Maria or Carolyn, could you please take a screenshot of, we have to have some kind of record of this virtual session, maybe of the panelists from their side. So we have to document this in some way. So our overall approach in AgMIP has not changed from 2010, which shows, I think, also it's like the strength of it. So from the very beginning, it was never just about the biophysical side. It was always from the beginning linked to the agricultural economic models as well. So I think that this is also one of the real strengths and real reasons for the longevity, is that we weren't just siloed into the biophysical side. So we include agricultural models, both and physical. We have great climate scientists with us, led by Alex, of course, and biophysical and socioeconomic. So it's really all 3, and multiple models of them. So as you know, we do baseline intercomparisons with historical climate and policies and management techniques to evaluate and intercompare our models, do improving the model calibration. By the way, the model calibration team is, I'm not sure they presented this morning. I'm not sure they're going to be presenting this afternoon. very, very strong advancing the science of the calibration, and also working on the model, and many groups are working on the model improvements. Because we're working on this ever improving base of models, we are then able to do future assessments with future climate and future food systems, to really make what I call the projections of record of future agricultural production, trade, and food security. And from this, we can then work on solutions together in terms of adaptation. Increasingly, more and more, also we're bringing mitigation into the AgMIP mix, and then extensions to soil, soil processes, to water, to pests and diseases, to ozone, all the different things that this base of networked models and modelers really enable. You've probably all seen this before. We call this the flower diagram. That really is, I'm not going to go through every single one, but these are the 40+ initiatives that span really from global economics, through data and tools, very, very important, global gridded crop modeling, regional integrated assessments that bring it all together right on the ground where ag actually happens, and ag and food production, and a main part of the food system. Experiments and modeling interface also, again, right, linked to the folks on the ground doing the measurements, bringing them into the models, which were previously so separated. Cross-cutting themes, uncertainty still going very, very strong. Representative agricultural pathways, a huge advance led by John and Roberto. And, looking, always seeing how we can coordinate across these individual teams, but also as a whole, learn from each other to advance and build a more productive, sustainable, resilient, and healthy food system. So this is a great slide, but Alex, I think we might need to update it because I think we might have more research sites now, but this is a sampling of the AgMIP site-based research. And you can see that we're in basically all the major agricultural regions around the world. But if you have sites that that are not on this map, let's get with Alex and get your circle, star, triangle on the map. But you can see it truly is a worldwide linkage to research on the ground. Now, another part of it, and this is something that Martin Perrier, the very first head of the AgMIP Steering Council, said was, "Why are you all here?" at probably the very first meeting in 2010. And one of the reasons is that AgMIP offers publication opportunities to everybody involved. So we've just pulled out a few of a few of the recent papers, so we have trade-off analysis from the economists, from the regional economists, Bruno Basso working on the temperature trends and ET in the Midwest. We have 2 new papers with Francesco Tubiello on greenhouse gas emissions from food systems, and Ken, a wonderful paper led by Ken Booty on incorporating the trait physiology to support genetic improvement. So this linkage between genetics and crops is also very much, we're at the forefront of that. And then on the economic side from the global econ team, very important global perspective of a paper by Van Zeist et al. Are scenario projections overly optimistic about future yield progress? So these are the kinds of global facing decision makers who are delegates, for example, to the UNFCCC, helping countries and the global agreements on climate change to understand the underlying evidence about food. I think this is getting to be very near the end of the overview, but just want to say, and I have it right here, I'm not only the photos, but I'm showing you that these are the actual new books that were just released by World Scientific Publishing part of their series on climate change impacts, adaptation, and mitigation, the 5th volume, Handbook of Climate Change and Agroecosystems. These are detailed chapters on climate change and farming system planning in Africa and South Asia, authored by our leads of our AgMIP teams in the countries, plus the methods and the new development of the AgMIP Regional Integrated Assessment methods for the stakeholder-driven research in 2 parts. So we want to share with you the excitement about our new books. It's over 800 pages. So everybody in AgMIP has been busy. Finally, how to get involved in AgMIP activities. We need always help AgMIP develop and create new and utilize and implement new protocols for model improvements and applications. This is how we work. We work on informing decisions for societal challenges. So it's not just modeling for modeling's sake. We always do multiple modeling groups, modeler systems, and locations, as you can see from this very brief overview. We're very focused on intercomparing and improving the models and methods. So it's not a static thing in any way. We're always pushing to improve. And as I said, when we looked at the flower diagram, you see from being a network and working in our individual teams, but through AgMIP, we are connected to the full set of AgMIP activities, and those cross-team interactions are also very strong and just all there, as a resource. And then finally, we've worked very hard, and we want to work with everyone in AgMIP to ensure that there is inclusive leadership and participant structure with shared credit. This is very much the underlying principle of AgMIP. So please contact AgMIP to join or set up new activities. Join the AgMIP listserv to learn about new AgMIP teams. And with that, we'll turn to this was session 1 with the over 100 participants. It was really great session. And here's our lineup for session 2 AgMIP Marathon Open House Forum. And I'm going to turn over to Alex to lead us through this agenda. So I'm going to stop sharing and over to you, Alex.
Thanks, Cynthia. We're really happy today to have 4 different panels who will be talking about different elements of AgMIP, in addition to things that we heard about earlier this morning. Those earlier presentations are going to be made available online, so people can circle back to look for those if you were not able to attend. We're trying to keep each of these sessions quite short, and we will have 4 sessions now, followed by a short period of Q&A. And you can also put your questions into the Q&A function at the bottom of your screen, I believe. And then that will allow the authors to respond even in the course of the other people's talks. So at this point, let's get started with Klaas Nendel, who's going to be talking about recent efforts of the soils team.
Difficult to find the unmute button once you have shown your slides. Yeah, welcome from AgMIP Soils. Long time no here. You remember those were the guys wearing the brown hats once we had them. Mine is so worn out that I cast them into the bin now. So we need definitely some new ones, Cynthia. So reporting from something that has not done anything, that's not quite true. No, we have a paper out that was led by Bruno Basso. And this is actually an award winner, 2020 Agriculture and Environmental Letters. And that was about an activity that it is some time ago, but we had some simulations of soil organic carbon and nitrogen feedbacks on crop yields under climate change here. Since then, the group has been quite silent, but we have used the time and looked out for exciting new data sets. And we found one right in front of our own feet here in Germany. And we were contacted, in fact, for this by the International Soil Modeling Consortium. There are other modelers out there in the world, not only AgMIP. So here the ISMC gathers the soil modelers, a wide range of soil modeling expertise, while AgMIP is so far a bit more crop focused. It is the idea to bring those two communities a bit closer to each other to work at the interface of soil and crop. What they offered to us and what we found very exciting is a very rich data sets of a space for time substitution experiment, where they digged out soil cores, I mean giant soil cores, and put them somewhere else. And this space for time substitution approach sees 126 lysometers at 13 stations with sort of interchanged soils, putting soils into different climate. And we have hands on 5 different soil types here with 3 replicates grown under a crop rotation, mostly winter cereals, with 10 years of observation and a very rich data set on precipitation, evapotranspiration, seepage, capillary rise, soil moisture, and what you can dream of if you were a soil scientist or a roots person or somebody who's really into soil and crop interaction. Here are my 2 colleagues, Tobias Weber, and Tobias has been around for some while here in some of the AgMIP modeling activities. And Janis Groh joins us from the ISMC, he's also here in the panel today. And we're running to prepare this data set and start a modeling activity, probably not this year, but maybe early next year once we have this data set finished. Now we will invite people to have a look and see what's in there. Research question will be something around how well do crop models in predicting soil, water, and nitrogen dynamics when predicting yields? So are they right for the right reasons? It's lots about the feedbacks to soil and water, and nitrogen availability, and how much of the model performance in predicting yield and biomass do we sacrifice if we try to get the soil water fluxes right? And then last, are models actually fit to also simulate carbon and nitrogen dynamics when they're actually meant to be crop models? And also here, and this is something that I had on the screen in earlier meetings as well, the global microlysometer network is still going on. This is about nitrogen mineralization from soils and see how much is actually in there when there is no fertilizing going on. This one actually has been severely impacted by the COVID-19 because of restrictions to the field access, because the microlysometers have been buried down in the field and they need to be seen every now and then. And if the people are not allowed to go on the field, then data points are missing. We have no clue at the moment how the situation is in many of the sites. 4 of them have officially dropped out because they were not able to sustain this. We're still hoping to get this data set ready, and many sites terminate this year. Proposal funding is awaiting for approval to get a person to work on the data, and we hope to have this ready for modeling in 2023. That's it. Thank you.
Thank you very much, Klaas. You motivated me to find my AgMIP climate hat, and I'm happy to recall that last time we were in New York for a meeting with lots of hats and lots of people. Looking forward to that in the future. Our next speaker is Montse Salmeron from University of Kentucky, who will be speaking about the soybean initiative. And if you have questions for Klaas, you don't need to wait. You can put them in the Q&A. Montse, over to you, please.
Thank you, Alex, and good afternoon, everyone. I'm excited to have the chance today to share some results from our team. First, I would like to introduce the rest of the team, the coordinators, and Kritika Kotari, that's the postdoc working closely with me at the University of Kentucky. And this is the group of data experimentalists, climatologists, and crop modelers that have contributed so far to AgMIP soybean. The goal of AgMIP soybean is to conduct soybean multimodal evaluations with key experimental data to improve models. And there were several reasons why this was. It was a pressing need to start a soybean team within AgMIP. Since we started the soybean team in 2018, we were lucky to get funds to support our activities that has helped us to get to a good start. Since we started our activities, we completed the first study that was a CTWN, CO2, temperature, water, and nitrogen sensitivity analysis after calibration under baseline conditions. We completed already this study, and then we started evapotranspiration multimodal efforts with data from 2 sites. One is Nebraska, and shortly after that, we started the study, a multimodal study with data from Canada. We are now wrapping up these studies, getting the last results from modelers. And the next activities that we have lined up is a CO2 multimodal study and another with for model evaluation for crop nitrogen and nitrogen fixation. Yesterday, we had a side session where we discussed the preliminary results from the soybean ET studies, that since we are now getting the results, and so it was a productive meeting with good feedback for improving the final sensitivity analysis and good suggestions to present the data. And we discuss and line up the publications we have for this study. And today I will share briefly some of the key results from the study that we already completed. Recently, we submitted a publication from this first study. We had 5 locations for calibration under baseline conditions, 9 participating soybean models. And in this first publication, we show the sensitivity analysis in yield in response to temperature and CO2. We have 2 other publications that we plan to submit. One is evaluating the in-season growth and reproductive partitioning and to find opportunities for model improvement. And the next one, we are presenting model evaluation for simulation of crop nitrogen dynamics and nitrogen fixation with data from 2 sites that have actual measurements from nitrogen fixation and crop nitrogen. The first question that we had from results from this first study is, does the model ensemble is useful for simulating, reducing uncertainty in yield simulations for soybean, and how many models do we need? So we find that yes, the model ensemble is useful, as you see here in red, to reduce error, but it was not the best predictor. We did not rank first. And we need 4 models to reduce error in soybean yield simulations. Adding additional models did not reduce further the error. We explore more the question of using a model ensemble to reduce error under baseline conditions. And modelers might be interested in keeping their preferred model, but not drop their model randomly as they create an ensemble of more models. So we explore the question of when we impose the condition that a given model is always present in the ensemble. So we saw that under those conditions, an ensemble is still valuable for both models that have more or less experience, because in a given location, the ranking of models across location is different. So we see that there's an opportunity to reduce error largely for models that have high error, but however, for models that rank first and has low error, the increase in error is relatively lower. So the model ensemble is still useful for both best and relatively worst performing models. After calibration, we looked at the yield response to changing temperature and atmospheric CO2 to analyze the uncertainty in model simulations. And we see that there's large variability in model responses. At the top, you see the yield response to temperature. This is the percent yield change from the baseline. At the bottom is the response to CO2. The figures are sorted from left to right, from the coolest to warmest location. And you can see in the coolest location in Argentina, for instance, under a +3 degrees Celsius increase, models did not agree in the direction of the yield change that goes from approximately +25 to -25 yield change. However, we see that models show the expected response, but of different magnitude. And that there's an opportunity of reducing this uncertainty and variability across models with parameterization with temperature and data from increased temperature and high CO2. If we look more closely at the data, this is results from the yield change under a +6 degrees Celsius. We found an unexpected effect of calibration. So for instance, in the top location in Argentina, after blind calibration with phenology only or full calibration with in-season growth data, we see an expected effect of calibration. However, the multimodal ensemble was effective to reduce as effect of calibration, as well as the variability, the extreme values from individual models. Also, we compare the yield simulation from the ensemble, the expected yield change under increasing temperature from our ensemble, which is the symbols in red, with data from the literature, from experimental measurements. And we see that the model ensemble is also useful to place the expected yield change under the range of values observed in the literature. We found similar results for the yield response to increasing CO2. The model ensemble is the dashed line here, and there's large variability across models, but the ensemble reduces uncertainty and extreme simulation from individual models. But also when we compare with data from the literature, the ensemble, the horizontal line places the yield, expected yield change in response to CO2 within the range of the results that we expect from the literature. Something interesting that we saw is that based on the literature, is well known that the increase in biomass in response to CO2 is relatively greater compared to that of yield. So there's a decrease in harvest index under increasing CO2 that models did not reproduce. So there's a need to explore what mechanism models need to follow to reproduce this response. This is the end of the talk, and I would like just to thank all the participants in AgMIP. Thank you.
Thank you very much, Monse. Really great to see that work, and really appreciate your efforts and Critica's to keep that all going forward. So again, you can ask immediate questions in the Q&A, but our next talk is going to be given by Raymond Roeder on barley efforts. Raymond.
Thank you. So, can you see it?
Yes, but please swap the display so we get the full screen.
Yes, sorry, duplicate. So here we are. Good day to everybody. So thanks for the opportunity to introduce a new element in AgMIP, global barley. And this morning there was already a short introduction by by my colleague Hennady Bracho-Mojica, who showed some preliminary results of the first steps. And I would like to show you the next steps that we are planning. But first of all, so Hennady is actually coordinating this. I'm just a little bit supporting her. And we started as an activity of Barista. That is a SUSCOP ERANET project. Barista means Advanced Breeding Tools for Climate Resilient Barley in Europe. And in that group, we are just two modeling groups, actually the Göttingen group, my group, and then Roberto Confaglionieri and then Livia Pagliari. So only those two groups. Then we invited some old Maxur research groups from the Maxur project to join us on this global barley exercise. And of course, almost all of them are also AgMIP members. Then at some stage, Senthold came because Senthold is also participating in this exercise. He said, why don't you make it an AgMIP exercise? So here we are. Good. Yes, so this morning there was already an introduction, but for those who haven't heard, I give just some background. As I said, it is an activity of Barista. And Barista project spans from Finland down to Spain, from Estonia to Italy and so on. So they are multi-locational trials. But this global barley study is one particular activity. And the first objective is to investigate to what extent an ensemble of widely applied crop simulation models and its members reproduce the relations between flowering time and yield of spring barley under very contrasting environmental conditions. The second one is to examine then the relative importance of genotype and sowing time on the yield performance in those different environments. The third one is to assess and compare the model performance of the ensemble members and analyze possible deficiencies under those contrasting conditions and the causes of cause, and then eventually to end up with to identify required model improvements for capturing abiotic stress impacts on yield for different G/E combinations. And this is what we call a kind of first phase, but we already have ideas to follow up a second phase, which would then be more specifically on model improvement and especially on model-aided idiotype design of future climate resilient barley, because that is also a major activity of Barista, which we do with Roberto and others. So, but now I'm only talking about the phase 1, which consists of 4 different steps. It was launched last year during, we were already in Corona times. It has been planned as a 4-step study. And now we can, steps 1 and 2 have been completed. Hinali reported this morning. The first and step 3 is to be released next month, and step 4 then in September. So step 1 is on calibration of barley crop simulation models. Actually, we have at the moment 9 different models, and the calibration is under low stress conditions. And sites we have been using for this is Halle in Germany and Adelaide in Australia. And we have some reference cultivars for those 2 sites. And then we have a number of HEP yield lines. This is a special set of germplasm produced by Klaus Pillen and colleagues from Halle University. Actually, Klaus Pillen in collaboration with a worldwide network on barley. Step 2 is also completed. That was the model validation with the calibrated models for Halle, Dundee, El Karak, and Adelaide. So here we looked at low stress and high stress trials, also for these reference cultivars and the HEP yield lines. And now it's to discuss, and we have discussed that internally. Step 3 would be a kind of sensitivity analysis. We yet have to finalize it, so your input is also welcome. The idea is that we use the models from step 1 and 2, and then look at the effects of sowing, 6 different sowing times on phenology and final yield, also looking the effects of increasing plant available water capacity. We would do that for the baseline conditions, 81 to 2010, for potential and water limited production. So, and then again for the same cultivars. And we have a few more ideas how we would set up this sensitivity analysis. So with step 1, 2, and 3, we would have a complete model evaluation. And then step 4 would then be the simulation of barley potential and water limited production for baseline and future climate periods. And here we would then work with 4 sites, 2 soils, and then future climates for the period 41 to 70 with 7 GCMs, and looking not only in the changes of the means, but also changes in variability. Actually, I should add Mikhail Siminov from Hotramstedt is also part of this project and of this exercise using the last generator. We would work with 2 RCPs and of course with elevated CO2 levels accordingly. And then the last thing would be that we would look at adaptations to climate change, especially soil amendments, sowing, and cultivars. But cultivars here in this kind of phase still at a relatively simple way, like early, medium, and late. And as I said, so it has been launched in May, and so we hope to complete these steps this year. And here are the sites. You see they are quite contrasting. Indicated here are the black dots gives you the sowing date, the harvest date, and the open circle gives you the sowing dates here for Dundee, for Halle. So from the Atlantic climate to Central Europe to Al-Karak in Jordan and to Dubai. We didn't include Dubai in this exercise because here really salinity overrules or salt stress overrules all the other ones. And then we have Adelaide. And as you see in Dundee and Halle, we basically look at, it is nitrogen deficiency, Al-Karak and Adelaide, it's drought. And here you see what we want to do in the sensitivity analysis. The window of moving sowing dates is indicated with the blue range. So we have planned a number of manuscripts. First one, intercomparison of 9 barley crop growth simulation models in contrasting environmental conditions. The focus is on flowering time and yield. So that's the results from steps 1 and 2. Then second one would be on shifts in barley phenology and associated agroclimatic conditions under alternative sowing and future climates. Steps 3 and 4. And the last one would be effects of drought risk management strategies on yield and yield stability of barley under current and future conditions. I put here step 4, and consequently here would follow that we would go into model-aided idiotyping, and this Barista consortium, as I said, is so that most are geneticists, molecular biologists, breeders, and agronomists. So they do multi-locational field trials, phenotyping. We get wonderful data sets. So that's a wonderful collaboration, kind of collaborative modeling, you could say, with the goal to develop climate resilient barley cultivars. And these are the current groups involved. We have Göttingen with Absim barley, we have Milan with Armosa, Aarhus with Daisy, then we have Mendel University with DSAT, we have Senthold with DSAT Enwheat, Christian Kerselbaum and Eva with Hermes. We have Monika, Klaus Nendel and others, Sirius with Mikhail and Woforst by ourselves. Actually, we have recently got requests of 2 other groups that are joining, but we want to keep it at this, just to say that for this phase at least. Okay, maybe the last thing, we also recently got approved a project under the SUSCOP ERANET called BRACE. That's then really on adaptation of barley, and that's globally going beyond Europe, and it would focus on adaptation to drought and heat and the interaction of drought and heat. Thank you very much.
Thank you very much, Raymond. Very exciting to see that going. And I'm amazed you were able to get such a perfect diagonal line of all of your sites across the world. That's quite an amazing thing. So at this point, we have a short time for questions, and invite the panelists to comment and open the floor a little bit here. You can raise your hand using the raise hand button in the participants list. Or you could put something into the chat. Hopefully you've noticed by now that there is, we have also been posting the bios of our panelists. I saw a moment ago we had a hand up from Isaac. Isaac, would you please like to ask your question?
And just very quickly, we do have Gopal as part of this panel.
Oh my gosh, I'm so sorry, Gopal. I've jumped ahead. Thank you, Eric, for correcting me. My apologies. Gopal Kakani is actually up next before our Q&A session. So Isaac, again, my apologies to you as well for calling on you a little bit early. But yes, Gopal is the last panelist to speak on bioenergy and smart farm. Thank you.
Thanks, Alex, and good afternoon, everyone. Can you hear me properly?
Yes.
Yes, go ahead, please.
Okay, so I just wanted to bring into context some of the work that we are doing that's related to bioenergy, and I thought this would be of interest to several of the modeling groups involved. So this project called Smart Farm Systems for Monitoring and Analytics for Renewable Transportation Fuels and from Agricultural Resources and Management. Next slide, please. I'm actually out in the panhandle of Oklahoma on our Smart Farm site. So you might see a little bit of lag or disturbance in the communication. So this particular project is on establishing validation sites for field level emissions in terms of quantifying from grain sorghum in the Southern Great Plains. So along with me, we have other co-PIs from Texas A&M and Kansas State that are participating in this project. So the overall vision of this project is to collect gold standard greenhouse emission data from grain sorghum, especially that's used for biofuels. So, and here we're measuring sub-acre resolutions of soil parameters and also field level emission fluxes. And this project is funded through the Department of Energy ARPA-E program, and it's a 3-year project. Next slide, please. So one of the major goals, all we have, why be sustainable? Probably we have witnessed this, avoid mass migrations on the earth. Next. And also disaster-induced displacements worldwide through floods, droughts, and several other climatic events that have been rapidly ramping up in the recent years. Next. And finally, probably we can delay our journey to the final frontiers where no human has gone before and probably extend our life on the planet. Next. And also, this particular program contributes to the Sustainable Development Goals in terms of clean energy, climate action, and also several other aspects of the Sustainable Development Goals. Next. So one of the major scenarios in terms of achieving this negative emission technologies in reaching the net zero emissions. So if we need to get through that net zero emission scenario to the baseline of 2 degrees centigrade increase, so we'll have to use these carbon removal technologies. So we might have the conventional abatement technologies or technologies that minimize emitting or capturing, but finally the carbon removal has to come through the farms or agricultural production systems so that we can actually achieve this net negative greenhouse gas emissions. Next, please. And also there is an increasing interest in terms of the carbon pricing. Say right now it's priced around 80 to 90 billion dollars in the worldwide market, and it's projected to go up to about 250 billion dollars, the carbon pricing market. So there's a huge interest and also a huge economic incentive to the producers or farmers to get involved in this carbon markets. And across the world, almost about 45 countries are actively implementing these policies, and there's a growing interest in even in developing part of the world. Next, please. And both the developed countries and developing countries have determined contributions. For example, the United States until January, we were proposing to go to about 26 to 28% by 2025, but now we are at 50% by 2030. And the latest call by President Biden is towards that. And also EU and its member states are committed to binding targets of at least about 40% reduction in the greenhouse gases by 2030. So these set very big goals or targets for the contributions that farming sector can make in terms of minimizing these greenhouse gas emissions, at the same time trapping carbon into the ground. Next slide. And for example, here the California cap and trade over the past few years since 2013, the credits they've accumulated more than about $14 billion. So this opens up markets to several regions within US and also around the world, if this sort of programs are implemented in terms of helping the farmers gain additional benefit from what they've been doing so far. Yeah, next. And these are some of the methods that we use in terms of increasing organic carbon storage and also promote a net removal of CO2 from the atmosphere. Probably increasing productivity, cover crops or no tillage, or incorporating manure or compost addition, and also improve grazing and land management. So there's several methods that we can adapt to achieve this goal. Next. So the OSU Smart Farm, the concept here is we're using several approaches in terms of developing this gold standard data set for carbon dioxide, nitrous, methane, and water use. So using the crop management drivers, especially the crop, and also the fertilizer, irrigation, and other management practices, atmospheric drivers, measuring the atmospheric variability across these large acres that we are working on, and understanding the soil drivers for these emissions, like the organic carbon, pH, texture, nitrogen, and also using technology, the state-of-the-art technology, trace gas laser analyzers, and eddy flux systems to monitor these gas emissions. Next. So as I mentioned, we have a huge team that's totally dedicated towards grain sorghum, but there are other teams as part of the Smart Farm that are looking at corn, soybean rotations, corn, and other crop rotations, and rice. So there are total about 15 sites across the country where this gold standard data would be available very soon. Next slide, please. And one of the things I was thinking is probably bringing in some of the AgMIP teams and then see if he can play an advisory role or get involved in actually pulling this data into some of the modeling programs or building new subroutines that can predict nitrous, methane, and other greenhouse gas emissions. Next slide, please. So for the grain sorghum, especially we're targeting Kansas, Oklahoma, and Texas because it contributes to about 5 million acres of grain sorghum is grown in this region. And with an average yield of total yield of about 365 million bushels of sorghum. Next. And again, click next, please. So we're measuring the greenhouse gas emissions with farmer participation. So we're using eddy covariance systems to monitor carbon dioxide, water use. And also we have sub-acre resolution soil moisture and temperature sensors, 4 sensors per acre, using the laser trace gas analyzers for measuring the methane and nitrous fluxes, and ground truthing through soil and plant sampling, very high stringent QA/QC, and finally data management in collaboration with Lawrence Berkeley Lab. Next, please. So these are some of the pictures. Actually, right now I'm sitting on one of these sites here in Oklahoma Panhandle. So we have this grid layout for some of our soil moisture and temperature sensors. Next slide. And the data is already streaming from these sites. We just kicked off this project earlier this year. This is a show of the soil moisture and temperature probes where the data is being streamed online and displayed in real time. Next slide. And this is our setup of the eddy flux measurements for methane, nitrous, and carbon dioxide gases, where we are be monitoring 24/7 over the next 3 years. Next slide, please. And these are some of the QA/QC that we do online using some of the Flux Suite software from Lycar, and also in integration with the Campbell data loggers. Next slide. Yep, next, please. And this is a glimpse of the nitrous and methane data collection using the trace gas laser analyzers. We're in the process of actually getting this linked up with our other flux measurements and then calculating the nitrous and methane fluxes. I think that's, so beyond that, we're just collecting the gold standard data here, but beyond that experimentation, what is needed is a conceptual design for a data model platform for quantifying this carbon removal into the soils, or actually putting in carbon into the soils, and also minimizing the nitrous and methane emissions, because all of these contribute towards the carbon credits for the producers, irrespective of the region. So moving this greenhouse gas monitoring networks into model validation, developing models, and then actually extrapolating them to larger farms, say the 5 million acres of sorghum that we are working here right now, in terms of creating a market for carbon for grain sorghum, similarly for corn and others. So that's my take on this, and I'll be happy to answer any questions later. Thank you.
Thank you very much, Gopal, and I appreciate you joining from out in the field. It's a reminder that we're not just working on computers and virtual crops. There's the real world out there. That's the motivation for all of it. Yeah, there's the turnaround view. All right. Okay, now it is time for the panel, and let's open up with any questions that were there. And I had earlier called on Isaac. Isaac, would you like to ask the first question, please? So Isaac, at least your hand is up, but it looks like you have to unmute yourself if you're speaking. Maybe we'll circle back to Isaac in a moment. Maybe I'll get things started. Gopal, in your presentation, you showed, I think, some really exciting field measurements that we could eventually link into models. I wonder if you have thought in specifics about the way we might use models to think about transferring the results from your Panhandle station to others. What types of transferability characteristics would suggest it would work well when looking for other sites for the same type of activities?
I think, yeah, so in terms of transferring them into the models, I think, because this is the gold standard data set that we are collecting. So one of the things is this is high resolution, both in space and time. So one of the ways is probably, we will also be developing summaries of these 30-minute intervals and also daily averages of these emissions. So as most of these crop models are, daily simulations, day-based simulations. So some of these can go in there. And the other here, the aspect is the soil moisture and temperature. And most of the crop models simulate that. And based on the literature, about 90% of these emissions are regulated by the soil moisture and temperature. So there's a good probably use of these data sets to actually build in new subroutines for methane and nitrous emissions in these existing models, or at the same time validate or test some of these existing models in terms of their potential to simulate these emissions. And on the broader scale, for example, as part of this, we're also building what we call as carbon intensity calculators. So in linking with the GREET modeling group, and we're also planning on developing our own pipeline for that. So some of those can be integrated into these existing models to actually say forecast for a producer what sort of carbon savings or carbon benefits that a particular producer can achieve on the farm.
Thank you. We're a little bit short on time, so I wonder if there's maybe one more question before we move on to the next panel. Raymond, I see your hand.
Yeah. It goes to Gopal also, wonderful data sets. So do you think it would not rather make sense that one uses models with sub-daily routines? Does daily make sense at all?
Yeah, some of these things, because the colleagues at Texas and Kansas, they've been observing how these emissions change on a sub-day time scale. So, and I think that's also critical to capture when we are talking about these emissions. So similar to what happens to transpiration, happens to these nitrous and methane emissions out in the field. So I think we can improve the models to do that, because we already have behind, say, for example, in DSAT, it's actually running on an hourly time step, but it's only outputting on a daily time step. So we have those built-in subroutines that are doing these hourly time step calculations, but I think we need to add this additional functionality to mix up with this type of newer measurements or data sets that we get.
Thank you.
All right, I think with that, we have to close this panel. Of course, the Q&A remains open and the contacts for all of the panelists are available through AgMIP if you want to follow up more individually. So thank you once again. Our next panel is going to be focusing on environmental stresses and the representation in various crop models. So we're going to start with a talk on pests and diseases by Simone Bergaglio. So Simone, over to you, please.
Thank you, Alex. I'm just turning on here and share my screen, which is this one. So thank you very much for this opportunity and also for the opportunity to hold the meeting on Tuesday, which was very fruitful for me. And I think for this initiative, which was born in 2015, so we have 6 years, and we were not able to build a community strong as the ones that we have just seen. We are a quite small group of people, but I think that initiatives like this one can really push forward an enlargement also of the audience and of the scientists that can join this effort. When we speak about plant pest and disease, PNP stands for pest and pathogens. We deal with one of the major constraints for losses of agricultural production, and which can affect different components of food security, not only the production quantity, but also the quality, the nutritive value of foods. And in this recent paper from Serge Savary and Laetitia Willoquet, who are co-leaders with me of this initiative, you can see these wonderful colored matrices in which in the rows you have the different pathogens, and in the columns you have different food security hotspots. And as you can see, there is a huge heterogeneity of the impact of pathogens and pests in the globe. So when we want to model and to use crop models coupled with disease models to assess these yield losses, we have to know that we are dealing with something that requires case-by-case evaluation, meaning that we need the reference data to calibrate the model which are targeted to the different areas. So as I told you, it is an open initiative gathering scientists with specific interests in the development and application of simulation models. And we were able to build a strong, small but very active group in the last years, because for the first time we were able to transfer the knowledge from one model, which is wheat pest, developed by Serge and Laetitia, to other wheat models. These damage mechanisms were formalized for different wheat diseases, and a paper was recently published where we also deliver a sort of a guideline and a step-by-step guide on how to do this on your own models. We are interested in transferring this kind of work to other AgMIP groups if there is also the interest from the other side. This is one part, so we are dealing with something which is impacting a crop, but also we need to develop model to simulate the disease severity and as a function of environmental and also other factors like, for instance, genetic resistance of the host crop. So we need different models to address this issue. And okay, I just go through this. I know that there is a Ken Booty, and here, this is a picture from his paper in 1983, and we know how to how these organisms act and how they affect crop growth and development. But as a matter of fact, today, the number of models which implement actively and are used to perform such an assessment is very scarce. So we have the knowledge to do that. We know which are the damage mechanisms, and we are also able to relate them to the different pathogens. There are also theoretical and also, I would say, coded models in which these are this effort is done. But currently, if you use, I don't know, you use many models, but the option to simulate pest and disease is not yet widespread. So the final aim objective of this initiative is to make this option available. So in a vision, also in the last meeting that we had, Alex asked us many questions, and I was also happy to see that the attendees after the meeting wrote me many mails, and I take this as the first step to build this community. But AgMIP has a great potential, because we have a lot of crop model already developed in the years, and you are improving them and making them more adherent to the real systems. We have disease models, generic models. We interacted with Willington Pavan during this meeting. He is developing generic models. Also Serge and Laetitia did. So these models are available. We need just a coordinated effort and protocols also to realize this coupling. If you would like to see, this paper is on, it's open access. I think so. Anyway, I can share. This is the key results from that paper that I just mentioned, in which we did this coupling. And one of the main outcome from this paper is that the impact of calibration is really huge, also in assessing yield losses. So when more data from the fields are available, and when experimentalists perform detailed and careful work in taking data from the field, then these models can improve and reduce the uncertainty. Of course, to upscale these kind of simulations to large areas, we need other expertise. I mean geography, I mean economics, I mean also geneticists, because as you know, the evolutionary potential of pathogens is much higher than the one of crops. And there are also trade movements, which are the major way in which this pathogen can arrive to new areas. So it's a huge domain, and that's it. I thank you for your attention.
Thank you very much, Simone. And yeah, I want to study your fourth slide a little bit longer in terms of all of the potential connections that we can do. It's you know, one of the things that I think is a feature of the later years of AgMIP is that the teams are starting to come together, and we're starting to realize that the Pest and Diseases team has a lot to benefit from interactions with the wheat team around some coupling areas and around the forecasting team in terms of other application areas. We're seeing this more and more across the AgMIP teams. Our next talk is going to be given by Lisa Emberson, who is going to speak about ozone stresses and how we represent those. Lisa, over to you, please. All right, Lisa, I see your screen, but I haven't heard you yet. I wonder if you could test your mic. I still don't hear you. I hope it's not just me, but maybe we'll give you a moment.
Just trying something else. Can you hear me now?
That works now. Thank you, Lisa.
That's good. Sorry, needed to plug in my Jabra. I'm afraid I can't get my video working, so you have the benefit of not being able to see me, which is probably good. Can you see the slides?
We can see them, but could you try presentation mode?
Yeah. Is that working?
That looks well. Thank you.
Okay, excellent. Okay, so sorry for the slight technical issues, but what I want to do is just give a tiny bit of an update on what we're doing with AgMIP ozone. And I thought I'd just go through and give some sort of background to this, sort of why we think that this AgMIP ozone initiative is important, and then also just to give a bit of an update of where we are with the activity. So firstly, why is ozone a threat? So I just want to flag a couple of issues here. We know that ozone causes visible injury. You can see some of the damage on a weak flag leaf there in the picture. We also know that ozone causes reductions in biomass, as seen from an experimental study on wheat, which was grown in Pakistan. And then we know that that translates into some sort of crop yield loss. We also know that there are a whole load of other physiological effects that ozone causes, so impacts on photosynthesis, monoconductance, transpiration, leaf area index. And I just wanted to highlight another one here, which is nitrogen use efficiency, where we can see that as we increase an ozone dose, then the effectiveness of the nitrogen that we apply becomes less effective in terms of producing nitrogen in the grain. And then finally, ozone is also an important greenhouse gas, and it also impacts on human health. So there are a lot of benefits to trying to reduce ozone concentrations in the atmosphere. So what do we want to try to achieve with AgMIP ozone? So currently, the way that we make ozone assessments follows this kind of procedure where we have empirical data, we can fumigate wheat plants within open top chambers, and we can understand how that ozone that they receive over the course of the growing season will result in some sort of yield loss by pooling a lot of data onto a dose response function. And then we can use that dose response function to assess yield loss across the globe. And one of the problems with this is that this is a very empirical approach. So we really don't understand what are the different interactions that are going on at the plant scale that are determining how that ozone is actually causing damage. So one of the things we want to do within AgMIP ozone is actually use crop models to substitute for those empirical dose response relationships. And that should allow us to get a far better understanding of many of the interactions that we know are important. So other types of air pollutants such as aerosol, other types of climate variables such as soil moisture, heat stress, and then how these might also influence things like water use efficiency and nitrogen use efficiency. So we can get a far better understanding of the damage and also the drivers behind that damage. So what do we want to achieve in terms of the AgMIP ozone activity? So we know that there are a bunch of crop models out there which are starting to bring an ozone module into the crop model. And we'd like to conduct a model ensemble exercise to estimate wheat yield loss under both the current, so for example, 2020 conditions, but then also out into the future, say to 2050. And when we look to the future, we'd like to assess the benefits of different emission reduction pathways. So for example, we could look at current legislation, and we could look at pathways that maybe would bring us to say 3 degrees C or 1.5 degrees C in terms of climate targets. We also want to try to raise awareness of ozone effects in the agronomic community, and the link to AgMIP is a really good way of doing that. And if we are able to do that, then we should be able to mainstream some of the tools that we will develop within this AgMIP ozone activity for ozone assessment. And then it can start to become incorporated into things like seasonal crop forecasting. And then finally, we want to develop advice for policymakers so that they have information to try to enhance food supply in the future, and where to put efforts in terms of mitigation, so reducing pollution concentrations in the atmosphere, but also how to adapt our cropping systems to try to avoid these stresses. Current status of the activity. So we have been active. We probably haven't got as far as we would have hoped to, but we do now have gap-filled and quality-checked wheat ozone empirical data sets for 17 locations or years of ozone treatments across the Northern Hemisphere. We've also identified a core set of crop modelers who have shown interest in taking part of AgMIP ozone, So we have models such as the DOSE model, WAFOS, Lintel C2, and the LPJ crop model. And I've just indicated in here our SUSCAP logo. This is a project which is looking at the impacts of air pollution and climate change on wheat across Europe. And it's now got to the stage where we will be able to use this project to really kickstart the development of the protocols that we need to develop for this AgMIP ozone activity, and to really start the modelling activities that are going to need to be done. So that's the current status of our activity. And then in terms of our next steps, I talked about those protocols, so we really want to finalise those protocols that will use experimental data to test the crop models in the next couple of months. We want to invite AgMIP ozone crop modelers to perform empirical model runs, and then we will analyse those empirical model run results. So that's essentially trying to make sure that our crop models work with our empirical data. Once we have that, then we will identify those emission scenarios that I mentioned, and then we will collate those data so that the crop modelers can then perform the runs to see what the current and the future impacts of ozone would be across that broader northern hemisphere. And then we analyse those results and then hopefully prepare our journal paper and any other outreach activities. Just finally, how to get involved. So if you have a crop model and you have or would like to incorporate ozone into it, then please get in contact with me. And if you want to hear any more about how important air quality and climate change are for agriculture, then we are hosting a session at the Sustainability Research and Innovation Conference next Tuesday, 9 o'clock UTC. Okay, thank you.
Thank you very much, Lisa. Very interesting set of results and plans, which I'm excited to learn more about. Our next speaker is Benjamin Sultan, who's going to be speaking about a proposed new protocol around extreme precipitation in low input systems. So Benjamin, over to you, please.
Hi, Alex. Can I share my screen?
Yeah, it looks like okay, it should be coming.
Okay, great. It should work now. So thank you, Alex. Thank you, Eric, and thank you, Cynthia, for giving me the opportunity to talk today about an idea of a protocol that could be dedicated to excessive rainfall and drought on maize yield in low input smallholder systems, with focus on impacts and attribution. And it's something that an idea that comes from discussion with Toshi Izumi, with Gatien Falconier, François Folder, and feedback from Alex. I don't know if you have read this very interesting paper on the excessive rainfall, showing that it could lead to maize yield loss of a comparable magnitude to extreme drought in the US. So it's here is one of the very first figures showing the maize yield response, the yield change in percentage for different categories of precipitation anomalies, with extreme dry on the left and extreme wet on the right. And you can see that the effect on crop yield is almost the same between those two anomalies. And in the same paper, they look at the response in crop models. So using the AgMIP global crop model data from historical simulation from 1981 to 2010, driven by AgMERA. And what you can see is that there is a quite good simulation of extremely dry anomalies response in crop yield in the crop models, but it's not so good for extremely wet anomalies, which in the models show an increase of crop yield instead of a decrease of crop yield. And this could be due to the fact that the processes involved in excessive rainfall are quite complex and not always simulated in the crop models. You have here a schematic of the different processes. And for instance, you have physical damages of excessive rainfall that are not simulated by the crop model that could completely destroy the crops with heavy rain and wind. It is also highly dependent on soil property, on topography, and also on water storage of the soil. But there are some processes that are simulated by the model that we could use to detect the effect of excessive rainfall, in particular nitrogen leaching. There are interactions between surface runoff and drainage, which determines whether increased rainfall intensity could translate into more or less water stress and also into more nutrient losses with nitrogen leaching, which depends on soil properties and also agricultural practices. So it's something that we could look at in a crop model. And we think that sub-Saharan Africa could be an interesting case study for at least two reasons. First, we have observed an increased rainfall intensity in the recent past, with a frequency of extreme Sahelian storms that have tripled since 1982 in the observation. And it is likely due to global warming, which increased the meridional gradient of temperature, which is one of the motor of the driver of the monsoon in the region, but also in other monsoon regions. And this effect is likely to increase in the future. So we will have more intense rainfall in the future in most climate change scenarios. So that's why this region and maybe other monsoon regions could be very interesting to look at. And there are also a group dedicated to low inputs smallholder systems in AgMIP that has showed that maize yield was affected by this increase of rainfall. But this amplitude was quite different from one site to another and model dependent. But they also found that yield losses were attributed to nitrogen leaching, and these losses were greater when nitrogen was limited. So an idea could be to look at this effect on sub-Saharan Africa as a case study, try to quantify the effect of excessive rainfall on yield using crop model simulation with diverse sites across sub-Saharan Africa, comparing model responses to drought and excessive rainfall under different conditions, trying to look at the specific contribution in the historical changes of crop yield, of drought, of excessive rainfall, but maybe also on heat waves and interaction between heat waves and drought, and also trying to attribute those events to anthropic global warming. So we could use what have been done by the modeling group led by Gatien Falconier, with 7 sites that span a range of climates and soil conditions and different fertility levels in sub-Saharan Africa, and the different crop models that have contributed to this group without any further recalibration that could be quite quick to do, without any model development. And we could also use climate simulation provided by Toshi Izumi from Japan, who simulates with his model historical climate simulation. We simulate the historical past with 2 different simulations. A simulation which is very realistic, very close to what we observe, and a counterfactual non-warming climate simulation with greenhouse gases emission of 1850, which means that it's a climate that has not been observed, but that would have been observed if the greenhouse gases emission was the same that we have observed in 1850. So comparing the differences between the two, you could look at the effect of anthropic warming on regional climate, but also on crop if we look at crop simulation. And we have 60 years of this simulation with 100 ensemble members for each simulation type. And it is at 0.50 resolution. And the simulation data have been bias corrected, which means that it's quite easy to use for crop modeling simulation. So an example of a protocol that could be made is to look at to perform historical simulation with different nitrogen inputs. And these two kinds of simulation, factual simulation and counterfactual simulation, and compare the two to look at the response of excessive rainfall and of droughts and maybe other climate hazards to go further into attribution. So there are important points that we need to think about and to discuss before doing anything. First, what kind of drought metrics that we have to use? There are several definitions, several metrics in the meteorological observation, in the crop model. We need to think about initialization of soil moisture and also of soil moisture diagnostics in the model. And to look at the possibility of including some other factors such as heat waves and interaction between heat waves and drought. We need to think about scale issue because we have climate simulation at 50 kilometers and not at the point scale. Maybe additional downscaling will be required. And also we need to think about attribution of historical changes of yield. That could be really great if we could do that. But the problem is that we don't have any long time yield time series in the different sites. So we probably need to think about another protocol if we want to do that, maybe at the regional level using FAO data or AgMIP yield data at maybe at the regional level. So I'm done. Thank you very much. Thank you again.
Thank you very much, Benjamin. That's really interesting stuff and exciting to see that what could be developed there. And that wet side of the spectrum is generally underrepresented, as we've seen in that paper. And we could be looking from year to year, we're probably going to have to understand heavy precipitation, water logging, the potentials for floods or other types of things. It opens up a whole other realm of model application that I think would be really exciting to explore. And as you've said, being able to build off an existing site and model structure is quite exciting. So at this point, we have a short period. We're a little bit behind schedule, but let's open up the floor if there are any questions or comments that people would like to make. The floor is open.
Hi,
Cynthia.
I'll jump in just to say from this morning at the forum, Senthil Deseng also put forward some new work that's looking on extreme impacts. And that's why it's great to have these open forums so that we can, I think, get the two groups together to see how they're each approaching the extreme climate events. Clearly, as we go forward, this is an area that AgMIP, it's great that some folks are really taking this on because it's clearly very, very key as frequency and intensity of some extreme events are increasing already and are projected to increase more. So maybe that we'll make a note and see if we could set up a call between these two groups that are beginning to think about some rigorous protocols around the extreme impacts. Thanks. And maybe Sonali put something in the chat, but maybe she could talk about it.
Hi, yeah, thanks, Benjamin. That was a great presentation, and this is, kind of the wet extremes is super interesting. I guess my thought is more at the landscape level, which I know, kind of exceeds the development you're looking at right now, or is kind of a next step. But as I understand it in West Africa, and correct me if I'm wrong, oftentimes there are quite a few, not just West Africa, in many places, floods can occur because of remote rainfall that winds up overfilling dams, reservoirs, and then kind of these releases happen from the authorities that aren't communicated downstream to farmers, and so can wind up in a more slow form flooding than an increased extreme precipitation event. So both of those things seem to be happening at the same time. I'm thinking of Nigeria in 2012, where there was a large kind of precipitation anomaly, but the actual 2012 flood event seemed to be instigated by a flood release. And so I guess I don't know if that would really differ from a crop model implementation perspective, but I think it could differ from the way that climate information, is incorporated, particularly if you're not seeing a precipitation event in situ. And it also gets me thinking about kind of in an AgMIP style, larger scale scenario development and kind of looking at the landscape level of how these floods could interact with crop production. So anyway, it's more of a comment than a question, but yeah, I'd be curious in the West African context how you might be thinking about that.
Yeah.
So Ben, yeah, go ahead.
Right. It would be it would be really important to look at this effect, and in particular for smallholder farmers that they usually have their crops in these flooding regions, and I think that would be really important, and especially if we are thinking about the fact that they are going to have more rainfall in the future. So maybe these crops would be more interesting in the future, or there will be some more additional risk for flooding for people cultivating fields. But maybe in a modeling perspective, you probably need to couple hydrological models and crop models. And I don't know if in the AgMIP project, if we have already some kind of coupling between hydrological model and crop models. Maybe it has already been done. I don't know.
So there's a little bit of effort on this. Some models like LPJML have a river routing model that can be connected. There's also been work with CropSyst and the VIC model in Washington State, for example, I know of. But this is not a devoted area yet and could be in the future. I know we're over time, but I'm going to take just 2 more minutes because the common theme across all of the talks in this session is that we're trying to increase the model capabilities in terms of representing these extreme conditions. So I wanted to just ask for a very brief response from both Simone and Lisa also. How do you suggest that we engage with modelers who are interested in this topic but don't yet have a module that responds to pests or responds to ozone? Is there a place in your project for those groups, or how might they determine if it would make sense? So maybe Simone, if you would take a first response, please.
Yes, I'm sorry, I don't have a simple answer, and I don't have a strategy, let's say, to foster this. But I think that the best way is what Lisa said in the last slide. So if people that are interested and are also listening to us are interested in coupling pest and disease models to the crop model, just write me an email, and then I think that we need also to organize a sort of mailing list. Or even after our meeting, I received many mails from the participants, and I think that I will organize it in the next days.
Lisa?
Okay, yeah, it's a really interesting question, Alex. I think I'd probably answer it by saying that some of the models that we've already identified that are able to, or are developing ozone modules within their model, encompass both radiation use efficiency models, photosynthetic-based models, and evapotranspiration sort of supply-demand models. So I'd say that those models are therefore developing methods that can be used in those types of models that can bring ozone in. So the kind of approaches are being developed. So I would suggest that maybe those people that have those types of models and have that sort of experience could then work with others who were interested in bringing this sort of thing in. The only other thing that I'd say, just in terms of the extreme event thing, which is quite interesting, is that obviously with the particular pollutant we're looking at, ozone, it tends to be very high under very hot, dry, sunny conditions. So one of the things we'd be really interested in as well is trying to understand how ozone and heat stress, for example, combine together to cause impacts. So I could kind of see how, you know, some of these activities within AgMIP can start to coalesce in the future, which would be quite exciting.
All right, thank you again to the panelists. I'm going to turn over to John now for the next panels.
Okay, great. Thanks, Alex. Yeah, like Cynthia said at the outset, in addition to the modeling improvement work that we've just been hearing about, AgMIP believes in using models, and these next presentations are going to tell us about a number of different activities, some of them fairly new initiatives and some of them ongoing to really use the models. So first, let's turn to Sonali McDermott from NYU, who will tell us about one of those.
Thanks, John. Can you all hear me?
Yep.
Decently?
I
Okay,
think so.
Great. Let me put on presentation mode. So thanks very much. And indeed, I'll be talking about some relatively new work that we are launching within this week, next week, very, very soon. And that is on mitigation, the convergence of mitigation and adaptation and their co-benefits in agricultural production. And this is work, part of it being led by Cynthia, Eric Mencos, Carolyn Mutter, who's not on this, but I meant to put her on here, of Colombia, myself, Roberto Valdivia, Tao Li at DNDC Art, and many, many regional collaborators. And I'll delve into that in a little bit. And so I'm not sure if you've seen, but Francisco Tibiello and Cynthia and many others had put out a recent paper articulating that we may be underestimating agricultural greenhouse gas emissions. And at the same time, climate change is here and it's progressing. And so decision makers are increasingly understanding that we need to be pursuing agricultural interventions at the nexus of both mitigation and adaptation, and evaluating their co-benefits, both in their contributions to, for example, the nationally determined contributions for climate change mitigation, and also to the Sustainable Development Goals, particularly ending hunger, but also clean water, sanitation, and so on and so forth. And so it's really kind of these interventions which range across a host of tools and technologies and techniques and ideas: soil carbon sequestration, intensification, the entry point for crop and livestock systems. These are these interventions, AgMIP and AgMIP protocols, assessment protocols, are uniquely situated to tackle. And so what we'll be doing over the next year, a couple of years, as we start these new projects, is really adapting and actually really advancing some of the regional integrated assessment protocols that we've spent about the last decade in AgMIP developing, largely from the perspective of climate adaptation, and now adjusting these to really incorporate the role of mitigation concurrently. And so what you're looking at here, and I'll walk through in just a second, is an assessment framework that we are putting together for a trial project in Bangladesh that has been recently funded by ACIAR as part of the AgMIP GRA Global Research Alliance partnership. And so, like our integrated assessments, our regional integrated assessments, we really start and end with the stakeholders to ensure that what we produce is both academically rigorous, but also usable and useful for decision and policy making. Stakeholders, and this could be decision makers at a range of scales, nationally, even internationally, locally. They have direct representation in this process through the co-development of these representative agricultural pathways, or RAPs, which really help us define an uncertainty space for regional agricultural development. And so those can take a range of manifestations, different scenarios or storylines of change, maybe more fossil fuel or business as usual development versus a more sustainable pathway that can now perhaps accommodate mitigation goals. We've developed methodologies to then link climate, crop, and economic models to look at trade-offs, and we'll be augmenting these, as you'll see in a minute, to look at not just the effect of various interventions from an adaptation perspective, but also what interventions can meet both mitigation and adaptation goals, and how can these be facilitated through various biophysical and socioeconomic processes. We have built into our assessment framework our ability to look at trade-offs. If you've been part of any of the economics talks that have gone on this week, we use the trade-off analysis model out of Oregon State, OMD, TOAMD, to evaluate some of these trade-offs. But in this context, we're also very interested in co-benefits or synergies in these interventions, such as those resulting on food security, on nutrition, moving beyond just caloric availability. And increasingly, we are being asked by stakeholders to examine the gender and social equity dimensions that could be associated with the adoption and large-scale rollout of adaptation and mitigation interventions. And the scope of all of this work is ultimately to be able to inform policies and programs that are now multi-scale. And so we have several pilot projects and around the world, really, from Bangladesh, Dominican Republic, Peru, India, Vietnam, which I'll discuss in just a second, along with Bangladesh, and Zimbabwe, which builds off our prior regional integrated assessment work. And so we're really looking at this in a global context with our regional integrated assessment approach. And I think that's one of the beauties of this approach, is that it can be both very indexed and tailored to a context, but also it is a set of protocols and an approach that can be applied in many different contexts. And so it gives us an ability to standardize across our assessments. And so I'll talk very briefly about what's asterisked here in Bangladesh, and then India, Vietnam, with extensions towards Latin America and Peru. One thing to highlight, and perhaps one reason that we're entering this discussion now, is that we are interested in developing in AgMIP, as we do, the model capabilities for looking at both mitigation and adaptation simultaneously. As I've mentioned, our regional integrated assessments were highly focused on adaptation using state-of-the-art crop models, and have been focused on yield stability, resilience to climate shocks, extremes, right, as we've heard, is a point of development, in addition to pest diseases and looking at trade-offs across inputs, factor productivity. But now we really need to also be linking with models that allow us to explore the mitigation space by way of agricultural greenhouse gas contributions, soil carbon sequestration, and the impacts and intersections that those have with both yield, but also resource use, such as water. And so there are many model enhancements that are needed to analyze both of these things together. And here are just a few: simulation of intercropping and different sensitivity to different crop management, seeding, planting density, water management, for example, the modeling of residue fates and cycling, and coupling with livestock and economic models. And so there's a lot of development, exciting developments that need to happen in these respects in order for us to fully resolve all these processes. And so I want to highlight just a few projects that we've initiated and that will be activated and that we'll be working on over the next year. And so we have a pilot project right now in Vietnam, very small, but leveraging results from the AgResults project in the Red River Delta, which had combined rice and soil models, which I'll show in just a second, for a climate crop approach, looking really just at greenhouse gas mitigation in rice-based systems in the Red River Delta under both current and future climate conditions. So that's a pretty constrained, just one part of our integrated assessment that's really focused on climate and crop, but resolving both the yield impacts and the greenhouse gas emissions and the and soil carbon sequestration. One of our newer projects, which we'll just be launching imminently, is in Bangladesh, where we'll be conducting more of a full integrated assessment, assessing the effects of climate change and management interventions which include things like water control, but also nutrient use and even crop diversification possibly. And also weaving now in the economics to look at the socioeconomic impacts, adoption rates, but also metrics and indicators associated with food security in regional rice systems. And so there are a lot of details on this project that have to be worked out, but we have ACIR funding to do this. And we have just now roped in amazing partners at CIMMYT and Bangladesh's Rice Research Institute and Agricultural Research Institutes. And so that will be a project that we will be undertaking over this next year, led out of Colombia. We also are working with our longtime collaborators at Tamil Nadu Agricultural University to assess the efficacy of the system of rice intensification, which is a comprehensive set of management principles in order to meet these MACB mitigation adaptation co-benefit goals. And there too, we'll be conducting more of a full integrated assessment, looking at food security and livelihoods under current and future climate conditions. And that work is funded by the Carnegie Corporation. And so I won't go into details on this. I'm certainly not a crop or soil modeler to delve too far into the details, but this is an exciting development. We are working with Tao Li at DNDC Art, where they've recently coupled for the Vietnam work, a rice model at RISA to DNDC's soil module. So what this allows us to do is effectively look at both the yield, adaptation, productivity impacts alongside some of the biogeochemical cycling that we need to resolve in order to really be looking at both emissions and soil carbon sequestration. And this framework, this modeling framework and coupling process is fairly flexible. And so at some point in time, it would be great to have a discussion of what modules and models could be woven in and out of this framework in order to update it and try to get that cross-model intercomparison. This framework allows us to look at several things. One of the important considerations with this framework is that it's been deployed and used in the Vietnamese context in the Red River Delta, and it is sensitive to some of the managements that might be important for the system of rice intensification or just rice adaptation and mitigation more generally. So this can be the time of planting, the age of the seedlings, for example, the type of planting, very importantly, the water management, particularly if we're looking at intermittent irrigation in conjunction with nutrient management. This model is able to resolve some of those processes and be sensitive to some of those management principles in a way that we haven't been able to fully represent prior. So this is an exciting development that we're interested in testing and examining and evaluating. I will sort of wrap up by advertising here. We actually have just launched a special issue, a special collection of papers on the co-benefits and trade-offs of food security for mitigation and adaptation in agriculture. As part of CABI Agriculture and Biosciences, we'll be hosting this, who are part of Springer Nature. You'll see the submission deadline as October 31st, but we can be flexible. So if you believe that you have a paper that can contribute in this vein, looking at the nexus of adaptation and mitigation, please do reach out to us, and we'd be very interested to consider a contribution from anyone on this call. And I think I will wrap it up there. Thank you very much for your time and for this talk. And yeah, I will be happy to answer questions. Thank you, John and all.
Great, Sonali, thanks. Yeah, it's really, really exciting development. Look forward to see this as it progresses. One of the things that Sonali mentioned was the regional integrated assessment framework that we've been developing pretty much since the beginning of AgMIP 10 years ago. And one of our aspirations has been to have multiple economic models along with some multiple crop and livestock models and climate. And yet that's been a bit of a challenge. And so, Sonali, I think what I'll do is I'll just hold off for the Q&A till the end. So we had a meeting yesterday, and Gideon Kruzman, who's going to report on it now, who leads the ex-ante impact assessment within the CG system, came to us a few weeks ago and proposed that we might sort of try to restart this initiative that we made an effort on about 5 or 6 years ago called REMIP, the Regional Economic Model Intercomparison Project. So Gideon's going to tell us about our discussions yesterday to try to restart REMIP.
Okay, thank you, John. I hope you can hear me.
Yep, sounds good.
Good. So thanks for that introduction. Yeah, I reached out a few weeks ago when a little after I received the information for this Teams event of AgMIP, to try to breathe some life back into the model intercomparison of regional economic models focused at the farm and household level, or even going a little bit further beyond that to the community and landscape level, but definitely thinking about it at the micro level. That's something that has been on the radar for quite a while. It's never been done before. There would be great benefits in doing it, but it never really got off the ground for a number of reasons, including lack of funding. So what we did for the meeting yesterday was we invited a number of the key people who had been involved in the past in developing the proposal, plus a bunch of people within our network working on these types of issues. So the model community focused at the household farm level, community landscape level, both within the CGIAR where I work, as well as within academia and advanced research institutes across the globe. Why now? That's a question that I'd like to delve into briefly, because we're just starting, so we have no cool results to present like some of the other groups. So I'd like to talk a little bit of why we're doing it, so the rationale behind it. So what many of you may know is that the CGIAR is going through a reform process, and that process offers scope for breathing life into REMIP. There is an interest in ex-ante impact assessment and foresight, and looking at socio-technical innovation bundles at different levels, including at that micro level for which the REMIP process is intended. So we're just starting, so we don't have much to report on in terms of reports and papers, but if we get our funding secured, then do expect reports from us soon enough. So if you can observe in the figure that we have up here is the AgMIP related process about model intercomparison and improvement that we know from a lot of the other modeling efforts. And we will be using that same kind of framework in what we're doing, but we will be doing it probably a little bit differently than others because of the way the starting point for where we came from. Even though we just recently tried to get this up and running, we had 27 people in our open house session yesterday, which was quite a nice number. So let me go into the one CGIAR process for a second and give you a little bit of a background there, which will explain a bit how where we're coming from, where we're going. So the one CGIAR process is about streamlining activities and structures in order to be more effective. And it's even more than in the past. It's focused on impact in what they call the 5 impact areas of the CGIAR, which which span the whole range of the SDG type of societal goals. So one is on nutrition, health, and food security. Another is on poverty reduction, livelihoods, and jobs. There is one impact area is gender equality, youth, and social inclusion. And then there is two impact areas, which are more on the environment. One is on climate adaptation and mitigation, so linked very much to the type of work that Sonali just reported on. And the other one is on environmental health and biodiversity. So the activities are meant to address address issues that will have an impact across these impact areas. So working in the six geographies of the CGIAR, Latin America and the Caribbean, South and Eastern Africa, West and Central Africa, West and Central Asia and North Africa, South Asia and Southeast Asia. And this is done in three main action areas. One is systems transformation, which focuses more at the big picture stuff at national and global level, at policy aspects, etc. Then resilient agri-food systems is the area where this process would fit in, because its focus is very much at the way that things fit into local agri-food food systems at the landscape, the community, the farm level. And finally, the last action area that we have, well, obviously for the CGIAR, is genetic innovation. So this is where we're working, and given the fact that there is an increasing interest in looking at ex-ante impact assessment of these things, we pick up on the notion of socio-technical innovation bundles, which was presented by Chris Barrett earlier this year, and which is based on the principles that it's an holistic approach combining technologies, policies, institutions, and cultural norms, that the agri-food system stakeholder participation is essential, that singular approaches involve trade-offs and externalities, and singular approaches lead to incomplete gains. So how do these socio-technical innovation bundles fit into livelihood strategies, farming systems, and local dynamic complex agri-food systems? How can they benefit from quantitative modeling? That is what our approach is about. And so looking at the projected benefits, about trade-offs, about the impact assessment. So we're not starting from scratch. Well, we've been within the CGIAR. We've done there is quite a bit of work on ex-ante impact assessment of technology packages. We've done reviews and individual studies. And we'd like to really build up from there. So our focus, from where we're coming from, is on the one CGIAR process. That gives scope for starting this up. But besides the one CGIAR process, there are other parallel activities that can be developed, taking advantage of the momentum that we're trying to create. So following the same types of protocols, but not necessarily focused on low income agriculture, and because there is this same type of modeling focused at farms in Europe, in the US, in Australia, which could be included in the whole process, but would obviously not be a focus of the CGIAR. So we're thinking about an approach that a kind of an umbrella approach with a number of different lines of work. This is also makes sense because we're dealing with different levels, from the intra-household to the landscape level, but also different types of models addressing different components of food systems. The different types range from mathematical programming models, agent-based systems, village levels, computable general equilibrium models, landscape simulation models, dynamic simulation models, and micro simulation models. And so there's a whole range of models that work on a fundamentally different way with fundamentally different data, which it's going to be kind of quite complex to get all these things together. And I'd like to leave it at that. I'm running out of time, I think. So over to you.
Okay, great. Thanks, Gideon. Yeah, and I'll just add that at the end of the meeting yesterday, we did plan for a few next steps to try to move forward with some funding opportunities, kind of building on the way the Global Econ modeling group developed, where initially they did have some funding to support some modeling groups, support development of some protocols and methods for assembling data and that sort of thing. But then since then have really, worked largely through a kind of a community of practice approach with collaboration, supported by, projects people had, that sort of thing. So yeah, so we're really pretty optimistic and really, again, thanks to Gideon for shaking the tree a little bit here and bringing this idea to us, and we were hopeful that this new initiative with 1CGIAR and its kind of, some of us would say, finally recognition of ex-ante assessment and its importance. And of course, Gideon's been part of that with the CG now for a number of years. So that's really exciting to see that's getting some real attention by the CG leadership. So we're optimistic this could move forward. Great. So we should move on now. Bruno Basso from Michigan State University is going to tell us about two initiatives. One new, I would say, and one that I think's been ongoing, right, Bruno? So, Bruno, why don't you take it away?
Thank you, John. I'll quickly share the screen. I guess you see it okay. So like you mentioned, John, I'll present this new basically initiative consortium that we felt it was overdue. Cynthia has introduced that yesterday, and we had some dedicated time, but here I will just briefly go over again, but also introduce within the AgMIP US consortium what activity we're carrying on and open to have other people engage in. So this initial participant, let's say founders of this initiative, is myself, Michigan State, Cynthia Rosenzweig and her team at Columbia University, John Antle at Oregon State, University of Florida is Jim Jones and a strong group on crop livestock modeling, and Sotirios and Arcontolis at Iowa State University Department of Agronomy. What we aim, I mean, the vision of the AgMIP US is really evolved because of what is happening currently in the US, mainly due more recently with the new administration and the sensitivity to climate and using agriculture as basically a potential solution. And so we really engaged and got together to design and build again this novel integrated system, which is based on the critical mass, multi-models ensemble that AgMIP has developed over the years. But this time linked with additional tools because they will really reinforce the whole system. So remote sensing, life cycle analysis, regional integrated assessment. And what is this for? It's not just to advance the science, as you'll see in a little bit, but it's also to provide a realistic support to US government and stakeholders by obviously listing farmers ahead, but all the agriculturalists involved in the agribusiness, including industry, companies, and private sector. With this ultimate truth, science-based, more informed decision on climate smart practices, or nowadays, often called as regenerative. It's just like we no longer want to reduce the impact of climate on agriculture, but we want to build it back up to building soil carbon and reducing greenhouse gas emissions. But so ultimately for circular, sustainable, and resilient agricultural systems. So some of the activities, certainly some of the activities, they're not, the list is longer, but we started by thinking at, conduct critical soil carbon, greenhouse gas emissions, crop livestock interaction, fruit and vegetables modeling. They're critical at a scale that it really is relevant for governments and stakeholders. So farm level to then scale through the assessment, both regional and all the way to the nation. With a close connection between the science and the economics, we plan to carry on regional integrated assessment to evaluate the policies, climate policies in different programs. There is a strong linkage with crop yield forecasting. As you know, I've been working extensively on that. So I see a close connection to that and to carbon and ecosystem markets. And so that's the two parts in bold is what I would like to share today as part of some of these initial activities that my lab was carrying on, and they basically transition into the AgMIP US. So the carbon markets, as you know, they're all over the place, but as much as they've been discussed, the confusion behind them, it's even greater. There is mostly a scope 3, like most of the carbons that is either quantify or model and transition is mainly to offset. So in settings, so companies that buy this carbon just to show that they're doing a good job. But there is a pretty detailed, cap and trade program in California with more detailed evaluation of, measurements as well as part of the modeling. So just to give you how strong the demand is, and so we've been modeling soil carbon. This is the latest data set from the NRCS, where soil samples have been carefully measured in terms of per layer all the way to 100 centimeters, and with stocks, so including bulk density. And so it's a very rich data set that has been interpolated across. These two maps here are here for a purpose. That the one on the left is what is used for the forest carbon inventory for the forest markets. And so one of the things that we don't have in soil carbons, obviously, is much easier to trade what you see, and paying for something that you don't see, like soil carbon, always creates a little bit of doubt. But the forest market has been successful, besides being able to measure trees much easier than through remote sensing or simple measuring the mass and NPP of the trees. But they were also isolated into macro areas, this benchmarking, such that, the conditions of climate, soils, and, the growth conditions were relevant and relative to each other. So if you had a forest that was 30 years old and the rest of the areas in the forest, it was 15, then the owner of the 30 years old forest basically could have claimed a flush, which is basically the difference between the 30 years and the 15 years, to say, I'm above, I did not do anything for, you know, this extra 15 years. And so there's significant amount of money going on there. The checks are in the range of millions of dollars for the sizes of carbon data. Well, in the soil, we have micro regions, but the variability, as you know, I work at a very high resolution type of work, and field scale it's large. And so what do we use? And so the initial thought is to start benchmarking with existing conditions. And there is lots of discussion going on. What are the best, you know, possibility of benchmarking in order to create these common baseline practices. So I've been doing a pretty heavy work on common baseline practices by isolating the same soil type, the same climate, the same practices, and see how different management compare. And these are additional sites, agencies, network that we are interacting with to be able to get this common baseline practices. So here it's with not knowing common baseline practices, you've seen that models are designed to ask the typical questions of, what if I go from a conventional tillage to a no tillage? So these changes of regenerative practices. The stars are farms data that I have. They do not have always, you know, soil carbon, but in some they do. They don't have changes of soil carbon, so they're always, you know, missing pieces. But going from this level at high resolution, we wanted to go again and create these common baseline practices. And so this is an example, just zooming in, and we're building for the whole US, building on where corn is grown, corn and soybeans, and high resolution grid weather. And so these are the locations of the weather information that we use. Basically, this is the example of that level at farm scale, field scale, the transition going from a conventional tillage to conservation. And the delta, the amount of yields that you gain versus the amount of, you know, the soil carbon that you would gain over 30 years of time if you were to do that. So now when you want to be eligible for like the carbon market, and I'm actually engaging in conversation with the US government to be able to evaluate the possibility of calculating the benefits of being in this system for many years, which the current way of giving credits does not reward farmers because it does not create additionalities. But because they've been in no-till and cover crops for 20 years, there is a paradox of saying, okay, no problem, I'm gonna till them in, now I become eligible. And so by being able to introduce this system about the flush, then a farmer will say, I am at 2% when the rest of the area doing conventional tillage is at less than 1%. I could be basically be rewarded for that amount of stock. And so it's probably a long journey, but we're getting closer to those conversations. And then you can zoom in to basically be able to see the changes in soil carbon from minimum, you know, type of management to conventional or conservation. One other thing is that we're doing in evaluating land use change, and it's basically the low productivity areas like marginal land, and what if we transition those areas to bioenergy crops. And so this is an example of running on a limited data set, only 28 literature sites, but we ran the ensemble, we ran 5 crop models that they could handle switchgrass and native prairies. And so we basically running this, and we have a novel way of coupling the ensemble with training the system with a suite of machine learning algorithms. So models and machine learnings coming together to create a meta model emulators, such that we can run the entire Midwest with that level of resolution at subfield in 20 minutes versus, you know, 3-4 days that you would have to run a complete sets of a model on a supercomputer. And so these are the example of DaySand, AppSim, Epic, Salus on those sites we confirm the findings of the mean the median being lower and the ensemble being basically the best predictor of reducing the error. Same thing in terms of salt carbon, where measurements of these 28 sites were available. And so again, the idea now is not just, when I talk to my friends, the biogeochemists, I'm always trying to make a point that you can only get salt carbon right if you also get the biomass and you get the residues that you are returning. So models have to be able to account for spatial and temporal variation of the addition of the residues, and so be able to get the yield right. And so this is again an example. And then just to conclude, because there is so much interest, not just in accrual of carbon, but also in reduction of greenhouse gas emissions. You probably have seen this work before, but what we found is that basically a quarter or a little more of the US Midwest constantly underperform with a nitrogen use efficiency of around 40 to 45%. So basically 60% of the nitrogen that is put on is lost without leakages, meaning not leaching, leakages without affecting yields. So they basically really, there's a possibility to use this approach to market greenhouse gas emission reductions through digital agriculture applications. And so with very simple economic, John, because we have lots of the data from the farmers, somehow over the years have we build the trust with them and providing them with prescription maps. And initially, I was able to engage with this large group of farmers throughout the US by providing imagery. So I made them an offer that they couldn't refuse. And so they start sharing the information, including the economics, to the level of how much they pay for insurance of their own health insurance and all the thing. Now, when you do the analysis and we convert the stability map ideas to a profit stability, because 1 year you can get the map being profitable in some parts and not in others. But when you start overlaying a profit stability, this, and I'm not showing throughout the Midwest, but it's just crazy to see how much money farmers lose on a big chunk of their fields. And they're still obviously in business because they get the majority of the areas. They are efficient in managing their fields, but potentially what I'm trying to convince in them is that they could make more money and reduce the environmental impact if they were to adopt a variable rate management. And so recently I was invited to write this piece in packaging this precision conservation, because you go from a profitability map that is now physically available for every single cornfield of the US with obviously some assumptions, but there is knowledge of where these low productivity areas are located. So the ultimate goal is basically that these farmers could get money from putting land to biodiversity and native vegetation. And so I have a NRCS grant that has basically provided a big chunk of money to give it to the farmers to incentivize the adoption of these regenerative practices, including the biodiversity on the edge of the fields. And so we know exactly where these low productivities are located, how contiguous they are, to avoid any zigzag or practical application. And so we have done assessment, and there are 2-3 papers coming out in the next month or so about addressing the benefits of the climate benefits from digital agriculture. And so they could sequester carbon on these areas and basically be paid both from the markets as well as from the reduced losses. So this is an example on a very large scale, zooming in all the way to the field where low productivities areas. And so when you run, okay, when we parameterize, this is another improvement and advancement, is that when you want to get to this scale, running a model, parameterizing a model just by using soil, for example, like this map, I don't know if you see the cursor, but the lower left map is a soil map. And if you run the model, any example of either ensemble or the single model, you will see that this is basically the output. If you run by capturing, because variability is not soil centric, because if it was soil centric every year, you will have a similar map, but maps look different every year because of the interaction between the climate, the soils, and position in the landscape. And so when you parameterize the model the way we do it with this ensemble, you basically, this is the simulated map, which resembles much more the yield high resolution 2 square meter measurements. And so with that in mind, when we parameterize, this is the runs that we do at subfield. You can click on any of these fields and you get, these are all the good areas. These are the bad areas, the low and stable areas. These are areas that they have depressions. These are areas that have hilltops, and how they change over time. So that's one example. And to conclude, you know, once, and there, I think there is great potential, and farmers are very excited about this, is that once we deliver prescription about different amount of nitrogen, if you see the gray, this is 0, no nitrogen is applied following, you know, the precision conservation. This is basically, they save, in this case, 160 kilograms. This is how much CO2 they're not emitting, and this is the carbon credits. The major point here is that this is verified, is because these maps are as applied, they're not manipulated. And so potentially the ultimate goal is they could upload this as applied map and get some rewards because they've reduced the application. And now there is a reference, which is the high and stable areas. What would you normally put? And so before we couldn't ever quantify, you had a reduction. Anyway, so that's converted into credits. And that's scalable across the US to see what potential there is per hectare. And so that's what the paper is about. Anyway, this was a series of examples. The important thing that you get is that we're really working closely with the agencies and stakeholders to have AgMIP as solution-based system to help, again, make better decisions for sustainable cropping systems. Thank you.
All right, thanks, Bruno. And so as probably everybody knows, we've long been hoping to have a real AgMIP active in the United States. So we're really optimistic that we're going to be able to move that forward now, and with, you know, this really pretty amazing foundation that Bruno and really you know, the modeling community more broadly has created to really, you know, have a robust science basis for the policy developments in the U.S. You know, what I have found to be really interesting is that so far in the U.S., all of the national climate assessments have been based on just quantifying impacts, not what to do about those impacts. And so we're really hopeful that now we can persuade the US government to actually move beyond just saying, here are the impacts, to saying, let's do something about them. And obviously, you know, the kind of work Bruno's doing here illustrates the potential for doing that in a way that really has, you know, scientific credibility, and, you know, cuts through some of this, you know, noise that we see in the media, you know, that's all over the map about these issues. Well, we're kind of behind schedule now. I do see one question in the Q&A asking Bruno about whether any of this work is being done on grasslands and rangelands. Bruno, could you give a really quick response to that question? And then I think we've got to move on.
You're muted.
I was typing the answer.
Okay.
To Hayden. Yes, we have not started a grassland, but we have the capacity to do, and actually it's a result of a new project that it's going to happen. So the models, because of the bioenergy analysis that we've been doing, the native vegetation, both all the models that you've seen, Descent, Salus, Epic, they have the capacity. We have soil, weather information, and so we have the capacity to do it, but we don't have results at the moment.
Okay, great.
Can I quickly just jump in and say there is an AgMIP grassland team that's led by Jean-François Susanna. They've done many model intercomparisons, and so we can definitely hook up with that work and then bring it forward into the kind of thing that Bruno was showing as well.
I was imagining that Aidan was asking about the US, because I was part of the rangeland, and they were point-based comparison of models for rainfall emissions over rangeland. So there is a paper in Global Change Biology that you can look at.
Exactly. So we very much have it within AgMIP. So as that we can, Hayden is the lead for the GRA, the Global Research Alliance. So the partnership, so it's US, yes, and also many countries around the world.
Right.
Great. So yeah, let's move on now to our last group of presentations. And so I'm going to turn to Francisco Tubiello from FAO, who I think is going to talk to us about an initiative taking the somewhat broader perspective on food systems, right, Francisco?
Hi, John. Hi, Cynthia. Hi, everyone. I hope you can hear me well. I'm actually stuck in traffic, pushing the boundary of teleworking to the extreme. But I take it you can hear me. So welcome, everyone. Thank you for inviting me to the AgMIP team meeting. So this presentation is brief and is basically to update you on the work that we've been doing with Cynthia and the Food Climate Partnership and FAO on further quantifying the emissions from food systems. So I have Eric that's helping me with the presentation. We can go to the next slide. So we've discussed this before, and we've known now for about, several years, but with the IPCC 2019, we started to put our fingers on quantifying those emissions from food systems, meaning beyond agriculture, beyond the farm gate, beyond land use change, to include supply chains, consumption and waste, and pre-processing. And various work, including our recent work on environmental research letters, is pointing to that, to about a third of all anthropogenic emissions responsible for food at large. So why does this matter? Of course, because with the Paris Agreement, there is a commitment to reduce emissions across the spectrum in all economic sectors and processes. And of course, this opens up a very large mitigation opportunity. What is needed, though, and I think this resonates with the work that AgMIP is doing, beyond focusing and defining a problem, is good data, right? And when we talk about good data, in this case, means long time series, so you can characterize a baseline and look at trends, but also country details and processes details. So we talk about agriculture, and you want to characterize things like emissions from fertilizers, from livestock, from land use change processes at the boundary of the farm gate, and so on and so forth. And so that's exactly what we've been doing with the work that ends up in an expanded database in FAUSTA. Part of this work is also in part methodological. The important thing here is the definition of a map from standard IPCC categories, which are used by countries to report their emissions in their national greenhouse gas inventories, to something that resonates a bit more,
I think we may need to advance the slide. Yeah, good. Okay.
Yes. Yes. Thank you, Cindy. And so that's important because countries report their emissions in this national determined contributions, using the IPCC language, which is a language that's been defined for certain reasons and processes, but it doesn't really pay full homage to delineating the weight of food within the inventory. And so we've, as part of the work that we're doing, we've provided a map, and this is something for you to keep when you have the presentations stored for the AgMIP people. I certainly don't expect you to look at this in detail, but just to mention here that in the IPCC world, we usually speak about agriculture, but what it's really meant is only non-CO2 gases from livestock and crops, and these abstruse acronyms such as LULUCF, right? Land use, change, and forestry, which has obviously, as everything, a reason for having been created, but unfortunately it hides the fact that most of the processes in there are agriculturally driven, such as deforestation, the burning of peatlands to make room for plantations, and so on and so forth. Next slide, please. So when you put this all together, and this is also results from the recent update of our FAUSTAT domain, you come up with a picture which is already been delineated through the IPCC reports over time, but gets updated every year, which says that developing countries, so the so-called Annex 1, emit about 2/3 of all emissions, and developed ones, largely the OECD groups, emits the rest. Of course, this is mainly also a result of size, both in area, population, livestock herds, and so on and so forth. So when you turn this in emissions per capita, then you see a different picture, which of course matters to policy. And the per capita picture turns upside down the entire picture that I just delineated, in that the per capita emissions in developed countries are higher, although they're coming down. They're higher than in developing countries still. Next picture. Now, this is more of an extended view beyond the farm gate, and it's directly a result of the paper in Environmental Research Letters that we published together with Cynthia and many co-authors, in fact, from Columbia University, New York University's FAO, IEA, and others. So what you see here is, first of all, the picture of processes within the farm gate, where we know that livestock, in particular cattle, through enteric fermentation and methane, dominates the emissions pie. And then at the conversion boundary between farm and ecosystems, you see the major emission from deforestation. Next. And just before we go to the food system view, just to provide let's say an illustration of the power of country data and the details that you can put in that data, you can, for example, provide a picture of the weight of countries' emissions. In order here, we have a top 10 emitters. So we always speak about global and regional trends, but at the end of the day, it's a handful of countries that really are responsible for most of those emissions. These, of course, has repercussions in how we set mitigation policies to achieve global goals. But also you can see here, different countries have different makeups. So if you look at China and India, all of their emissions are basically coming from within the farm gate. Whereas others, in particular among these big emerging developing countries, have a big weight from the land use change component. Next, please. And finally, and Cynthia, you let me know about the timing, because I'm speaking slowly, but I'm mindful of time. But I think this picture here is sort of the main message that we're trying to bring home with the paper and the work that we are doing currently, is that you basically, when you talk about food systems, you can think about three processes. One is the farm gate, we mentioned it. The other one is land use change, we mentioned that too. But the third one is that what we call pre and post processing, those are largely CO2 emissions. And in fact, even emissions, for example, from hydrofluorocarbons that are important and come into play, with regards to refrigeration of food. And so these three components actually globally have almost an equal weight. And what we find in our analysis by country and by development typology is, exposed, it's obvious, but it's not so obvious until you see it in the data. In developed countries, of course, the farm gate and the pre and post processing emissions are the ones that are most important. And that is the trend where most other countries, as they develop their agricultural systems, will move, provided, of course, that we are also successful, not only in moving agriculture forward in towards increased efficiencies of production, but also in protecting the ecosystems that are currently being destroyed. Next, please. Okay, this is new work, Cynthia. This is something that is going to go into our upcoming work also together with AgMIP, which is, all the data that you've seen, are based on robust guidelines and robust activity data, but are nonetheless estimates. What we've been doing, because the relevance of this information is for the countries that report their emissions through greenhouse gas inventories, is actually compare the estimates to what countries say their emissions are. So here you see only an aggregated picture that shows that, top panel is the agreement between the FAO estimates and the what countries report in so-called Annex 1, so developed countries. The estimates by country are usually very good, but the point here is that only the developed countries have a complete picture because they have to report by law, let's say by law, quote unquote, international law every year. Whereas the picture in terms of global knowledge in developing countries is incomplete, right? And so a database like the one that we are putting in place also serves to complement the let's say the spotted information that it's only available through UNFCCC. Next, please. Since we are a group that cares about data and databases, I just wanted to show here the richness of the FAUST database that we have developed together here with AgMIP. And you see there's 200 plus countries and territories covered with a long time series from 1961 to 2019 currently, which goes well over and beyond what's available from UNFCCC. Next. So I'll close with this, Cynthia, with just highlighting next steps for ourselves and the group in 2021 for this part of the work. We're currently working quite intensively in completing the country details of that picture beyond the farm gate to be disseminated. The plan is in time for the Food Systems Summit, so everything ready by end of August and most. We continue because the data is so relevant to coordinate both with IPCC, and AR6 is currently uptaking some of our most recent results, and the UNFCCC in terms of helping countries uptake the analysis that we're doing. And then at the end, because we want everything to be policy relevant, also try to develop indicators. So the per capita you've seen, but there are possibilities to do per agricultural value added, per cropland, and so forth. So with that, I thank you, Cynthia. I apologize for perhaps some noise from over here. And over to you.
Thanks, Francisco. One quick question that I'll just read off to you, since I think you're somewhere in transit somewhere, Francisco. Hayden
Right.
wanted to ask if the FAUSTAT emissions estimates use the latest emissions factors and methodologies in the 2019 refinement. Are they calculated using Tier 1 methodology for all countries? Maybe you have a quick response.
Yeah, no, thank you for the question. So no, I mean, we do use, as you know, the estimates are done at Tier 1, right? Because that's the only way that we can cover all the countries sort of at the same level playing field, at least in terms of the database. But we try to align with what countries are still asked to do under the convention. So at the moment, they're asked and most to use 2006, and that's what we've done. We are thinking though to do some adoption of the 2019, especially for areas that will make a big difference. I mean, I checked the coefficients, and one area that will make a big difference is the emissions from manure left on pasture, which in the new guidelines, I think are almost a fifth less than the coefficients of the 2006 guidelines. So that will be very relevant because of this, livestock, within the farm has the largest weight. And so being able to depict those emissions correctly would be particularly important.
Great, thank you for that clarification. So last but not least, Alex Rain, who is I think his official title is Science Coordinator for AgMIP. Did I get that right, Alex? And of course, involved in various elements of the climate-related work, is going to talk about the remote sensing and seasonal forecasting.
All right, thank you, John. Let me just make sure I have my settings right. Okay, so yeah, thank you for all who have hung on this long. I'm just going to do a brief update on some of the activities and discussions around remote sensing and seasonal forecasting that have been going on the past couple months, and also at the open house session that we held yesterday. So this is some slides I put together with Luke Monholland, who's with me at GIS, as well as Phil Alderman from Oklahoma State and Sotirios Arkantoulis from Iowa State. And I wanted to jump right in as to why we have remote sensing and seasonal forecasting together. And this is another way of looking at some of the things that AgMIP is doing. And in general, we have seen many of these things in our overall sets of presentations today. For example, we had an earlier panel on representing different hazards and disasters with pests and diseases and ozone, air pollution. We also heard about floods and other things. But all of these things, the reason we're trying to understand them is because these are the main drivers of year-by-year climate and related based variation. I have a big plus on here because we know that there are more and more hazards that we could, in the long run, include. And sometimes that requires coupling to other types of models. But overall, the aim here is that if we can represent these responses, then we can look across many different time horizons and support decisions in all of these different ways. So we can look back historically to understand what's happened in the past. We can monitor what is happening up to present day. And we can forecast at least at a variety of lead times with skill. And if, at a certain point, if we go too far into the future, it's no longer a forecast, it's now a scenario-based projection where we look at big changes to climate or markets or policies or socioeconomics or sustainability. But today we're going to focus just in this realm right here, which is how do we monitor things using remote sensing and other tools. And then how does this transition from monitoring into forecasting suggest the potential for coupling remote sensing, crop models, and seasonal forecasts for a number of applications. And it should also be, of course, just stated that you can use remote sensing in this historical period. You can even use forecasting in this historical period, what we call hindcasting, to get skill metrics and other things like that. So when we think about remote sensing and crop modeling, we've been very happy in this calendar year to have built up a collaboration with the NASA Harvest Consortium. So AgMIP and NASA Harvest are connecting in terms of understanding the entry points for remote sensing information into crop modeling. And likewise, the way that crop modeling provides important feedbacks to remote sensing in terms of validation and other higher level products that might be possible. So if you're not familiar, NASA Harvest is a academic consortium led out of the University of Maryland with strong connections to GeoGlam and remote sensing based applications around the world. But one of the things we're trying to do is map out the current lay of the land and have an understanding of how remote sensing and crop modeling have been coupled together in the past. And we, of course, have found that there are groups that have been doing this for many decades, often in small locations with well-observed fields, trying to get some combination of prediction and process understanding. But when we start to map this out, what we see is that there are several different areas of model inputs that are possible. So before the season even begins, there are remote sensing products that can come in, for example, land use or fertilizer information if we have indicators remotely. All of these things can help configure the model. Information about planting dates and cultivar traits can help us understand the phenology and genetic coefficients that might drive our model. And then, of course, if we have information about the soils, both nutrients, but also soil moisture, this can help set our initial conditions. Then, of course, during the season, there are many other places where historical information comes in, or where remote sensing information comes in, including the weather data, both in up to present and also into the future. We also can look at biomass and other vegetative remote sensing products to understand state variables within the crops. And then there are even ways of measuring fluxes in other crop processes, such as evapotranspiration or water stress or photosynthetic activity. And then, of course, at the end of the season, we also can use remote sensing to validate what we have. And there is a number of products that do this. So you can see this organization, and you can imagine that we are now collecting information about which products are used with which models in which locations and in what countries and for what types of decision supports. And of course, as we're documenting this, we're also seeing applications ranging from overall gaining credibility and trust in the crop models, but also being used remote sensing information constraining simulations to keep the variables tight with observations, for process understanding, decision support, planning of alternative farm systems, overall sustainability applications. And then, of course, if we have an ability to improve all of this, there are downstream food system connections. So one of the things that we're also trying to build up is crop modeling as an additional tool in the application space that currently uses a variety of different processes and products to make decisions. So when we're talking about these applications, we're talking about a range of stakeholders. So I want to emphasize that while there is a potential to serve farmers, farmers are not the only stakeholders that we have the potential to serve. There's a lot of work more broadly on extension, state level planners, food and other commodity value chains that need to know what is coming from the farm gates. Agribusiness is interested in the types of seeds or fertilizer or irrigation or equipment that they might sell with a benefit to farmers. And then, of course, there's a big user community around risk management, including disaster preparations and recovery and the insurance markets. Of course, when we look to what is happening right now, there is a big reliance on surveys and reports to understand what's happening in the field. Things like the National Ag Statistical Service and the USDA Foreign Ag Service, as well as FAO. There are many products out there that are based explicitly on weather-based estimates, so empirical models driven by weather inputs. These include things like the narrow forecasts and other empirical models. There are also direct remote sensing based yield estimates, such as those that are summarized in GeoGlam's Crop Monitor. And then, of course, where AgMIP is largely oriented is around these crop models and other process-based yield estimates. And here there's a question of, do we use one model or multiple models? But in all of these things, what we have to consider is the decision context, the scale, and the lead time. There are I think people who come at this problem from the weather community associate a forecast with a future projection of what will happen in a field and therefore the yield that will come. But in many of these stakeholder communities, the request for information is something about estimating what happened in the field prior to the reports and the official wave of commodities hitting the market. So if you have an idea of whether the harvest was good before anybody else, there's tremendous value to that. Within AgMIP, we have a global gridded crop model comparison that has run on a global half-degree resolution a number of simulations over the historical period. And if you've seen Christoph Müller and Jonas Jägermeier speak this week, you'll see that they're also working on sensitivity tests and future climate projections. But here I want to focus on a recent paper that we published just examining how well these models did in the past, because this serves as the basis of at least kind of a minimum ability to capture what is happening from country to country. So I know this is a very complex set of plots, but what you're seeing here are the columns of the top 20 producing countries for maize, wheat, rice, and soy. And then each row represents a different climate data set that drove an ensemble of crop models. So we won't go into all the details on this, but what I want to highlight is that different crops are represented better in the crop models at present. The maize crop seems to be the best simulated. These red colors indicate a high correlation with reported FAO statistics. Other crops like rice are not as well handled. And even within a certain crop, some countries and regions are handled better than others. And there's one other thing that this paper goes into, which is the difference between the climate data set that you select sometimes gives you better information, depending on the region. But this kind of serves as a starting point. We can do at least this good already with just global models. And the question is, can we do better? So when we bring this from a national scale down to a regional scale, we find ourselves making maps like this. This is the PDSAT crop model correlating with NAS county level statistics. And you can again see a lot of reds and oranges. That means we are doing pretty well at capturing the overall historical yield variability. So with this amount of skill, the question is, how can we take remote sensing information and the best weather inputs to set up some kind of seasonal system? So the first thing we might do is we might initialize around the planting date with the soil moisture. We might then use weather to progress up to present day, and then use sets of vegetation indices to potentially assimilate and constrain the model, such that when we get to the forecasting day, we are in the best position to use multiple crop models to make a probabilistic projection. So there's a lot of moving pieces in this, but this is the vision that we think we can build. And AgMIP is very well positioned to create the products and the ensembles and the expertise to put this all together. One immediate question that comes to mind is, what platforms are there for crop models that are capable of handling this type of inputs and the speed of projections and forecasts? We did a quick survey of some of the US-based product and saw that there are already kind of gridded sets of crop modeling systems that are available from Florida, Iowa State, Michigan State, and Columbia University is now developing one as well for at least internal purposes. Again, we're filling out these tables as a course and part of this work, but you can see that they use several of these use DSET. The Michigan State product has an ensemble of different crop models already there, but they all feature specific spatial resolutions. Some of them have remote sensing inputs, but most of them do not. And each of them have features. So we would love to expand this table and learn more about what people are developing, not only in the IT side, but in the application side. So the question is, are these up to the challenge of data assimilation and high performance computational applications? Here's just a quick example of the forecast and assessment of cropping systems, the FACS product that is developed out of Iowa State. I show this timeline just to give an idea. Back in 2015, this was developed at 2 locations, and over time it became 10 locations and then 3 states, and is now up to 12 states. This is a high performance version of the APSIM crop model, but just gives you an idea of the potential kind of growth that's possible if we build it from a strong foundation and have the computational resources to get it done. This is just an example of some of the outputs that come out of FACS. In this case, they're looking specifically at soil moisture anomalies. And if you look quickly here, you can see the dates coming up towards present, and note that there's a fairly substantial drought starting to become apparent in the upper Midwest as the season is progressing. So I'm going to let it get up to present day one more time. But just to give you an idea, this is the type of product that if we can develop it, we can start to engage with stakeholders further in terms of the best uses for these types of products. So overall, as we're developing seasonal forecast products, we need to evaluate our skill in the context of the application. So we are trying to find different products that might work well, depending on the region, the system, the season, or the hazard that you're trying to capture. And in this case, we're very much concerned about making sure that the skill is on a lead time that actually supports decisions, rather than finding out what the model said when it's too late. Likewise, we want to develop skill that also factors in the potential for probabilistic forecasts and risk management. So overall, as we're developing skill metrics, we have to decide which variable we are interested in, whether it's yield or water or carbon or biomass or something else. We also have to decide whether we're concerned about the overall average condition or maybe something more extreme like a threat score where we're particularly concerned about capturing the worst years. And then, as I mentioned before, the lead time is quite important in the skill. So the last thing I'll just note is all of the seasonal forecast development is also being undertaken with a watchful eye from the broader disaster risk community that is interested in understanding how longer term pressures are potentially setting the stage for substantial risks on the short term. So this is a diagram that came out of the UN Disaster Risk Reduction Office on the Global Assessment of Risk from 2019. And the basic idea here is even slow changes like global warming or population changes can eventually lead to market volatility. And when we do get crop failures, it can have cascading effects that lead to a lot of the negative outcomes that we've seen in different parts of the world in recent decades. So if we could have better seasonal forecasts, that becomes an early warning or at least a forewarning type program that they might be able to use. So this is the last kind of major slide I have here, just to note that part of this process at this point is scoping out where we are and why we haven't been able to go further. And these are the big questions that come up. It's hard for the crop modeling community up to present to understand what is actually available among remote sensing products and how consistent and useful they can be. We also are trying to determine the proper scale of simulation that would enable data assimilation to really be biophysically coherent. Part of that is to understand which processes really can be updated and constrained within the models. And all of this is limited by data across all realms, whether it's configuring the models, driving the models, or validating them. We also have seen that high performance computing is an important element of this, and in many cases becomes a limiting factor in who can participate in developing these products. But in the end, we're trying to match decisions with skillful lead times and connect with the best weather forecasts that are available. The other bottleneck that we've identified is that these products tend to be very regional by nature, and it is difficult, therefore, to blend them together and create direct intercomparisons as AgMIP usually does. And then, of course, we have to be cognizant of making sure that what AgMIP does is pre-competitive and not going to be challenging existing business models in a competitive space that would lead to a different set of interactions. So overall, please join us. If you want to learn more about what we're trying to build in the seasonal forecasting team, you can contact Phil Alderman. His email is on the screen, or myself as well. We're trying to scope out what's there, identify and transfer best practices, and plan protocols to link forecasting systems and compare their performances. Thank you so much.
Great, thanks, Alex. Yeah, a lot of really cool stuff going on there. A lot of us would like to ask questions. There are several questions in the Q&A. I'm maybe going to ask Cynthia for a little advice here. What's your feeling, Cynthia?
Yeah, because we're we're almost to our the top of the third hour, right? So I think probably we should say that we'll be following up with answering questions in the chat via email, and I think we should go to final thoughts from you, John, you, Alex, and I'll give a few at the end, and let's just take a few final thoughts and end at about 3, just as close to 3 as possible.
That's what I was saying too. So apologies to everybody who wanted to ask questions. We'll wrangle Alex to respond to y'all. Yeah, well, just a couple quick thoughts from me. One is, once again, I think this has confirmed the value of our web shop approach, or whatever we want to call it. I just think these 3 days have been incredibly productive, and I would just invite any feedback from anybody who's participated. We've tried to work on the timing so we could have global participation without some people having to be up in the middle of the night all the time. But anyway, any feedback or comments or suggestions would certainly be welcome. Another thing I wanted to mention quickly is that if you are new to AgMIP, do just shoot us an email to info@agmip.com with your name and email and institutional affiliation, so we can plug you into ongoing and future AgMIP activities. Yeah, and I think that's all I wanted to just do to wrap up, Cynthia. Alex, any last word from you?
I'll just say quickly that I'm going to at least hang around for 5 minutes and try to answer some of the chat questions. My apologies for running over, but I will at least stick around and do what I can here.
Great idea, Alex. You know, yes, apologies to all folks if we haven't answered your questions, but we'll try. But I think we will end with these final thoughts. First of all, it's just so fantastic and amazing to see the breadth and the depth of the AgMIP work across the teams. So thank you to all the team leaders and all the participants for advancing this important work. I think my second wrap-up comment is that we see the power of collaborative science. It's that when we do these detailed protocol-based work and advance those, they really do provide the science for solutions for the key food system challenges that then can be used by policymakers with this very, very strong base from AgMIP. They truly become the projections of record for that can really advance. And I think that we see over and over again the power of that collaborative science. It was great to see the flagships, you know, so some of the things that some teams have been going from the beginning, the crop teams, the econ teams, but then there are new teams that are constantly evolved, that are coming on stream, coming online, such as barley. I think that new team is, for example, that's one example of a new team that's forming. Soybean is really getting going, for example, that we heard about today from Muncie. Thank you so much. We needed the soybean team, and it's great that that's really coming online. And then we saw reviving teams such as the soils folks. Great soils, so crucially important. And REMIP, we couldn't be happier, John, that we're going to have multiple regional economic models to work with. Yes, fingers crossed. Final thing, my final thought is about the integration. For example, mitigation and adaptation. I think we're really beginning now to be able to have the tools. For example, demonstrated by the U.S. consortium work and the great work by Bruno, that the resilience work and the mitigation work can really now be really integrated together. I think we see so strongly the strength of that AgMIP works at the regional scales right on the ground. But then we also, you see, it's like global assessments, but with the AgMIP feet right on the ground in the fields. And I think that's another reason why the AgMIP work is so powerful. And my final thought is about model improvement. I think in the beginning, we were really focused on getting the protocols going for the intercomparisons, and that work has to continue. But at the same time, I think that we're really now also really being able to dive in much more to improve the models. But I think what we need, and here's a way forward thing, I think we need to document how we're improving the models, so that so that we can actually prove, yes, because, and I think some of the work has shown that as the models evolve over time, how are they doing a better job? So I think we need to work on evaluating the model improvements as well as the assessments.
Yeah, that's a great suggestion. Yeah.
Good. All right, that's it. Thanks, everybody. Thanks for sticking with AgMIP, not just for this session, but
Great.
through the years. Thanks a lot.
Thanks, everybody. Take
Bye.
care. Bye-bye.
And I guess if anyone wants to stay on, Eric, is that okay? People can stay on?
Sure.
Okay. All right. So if people want to stay on, the main meeting, then Alex could interact with them, right?
Yeah, I can hang on at least another 5 minutes, and
Yeah,
I'm
five
aiming
minutes.
for the
If-
questions that are written. So if you have one that hasn't been answered, throw it in the chat or the Q&A, and I'll try to get to these.
Okay,
At
why don't
least
you
the
do
ones
that?
that
I
are
tried to answer one. Okay, I'm gonna sign off, but thanks, Alex. Bye,
All right.
everybody.
Bye. All right. I'm maybe, since it's small and I don't know who's here, I'll take the ones that I see still. Let's see. I don't know if Ward is still on. I guess he had his hand up or for a while. Let's see. Doesn't look like it. Maybe one question that was asked a while back was by Hayden, and asking about grasslands and rangelands. I know that Cynthia and Bruno touched on this, but just to note that there are grassland simulations that people have looked at also in the United States, and there's a big effort to understand things like dual use wheat crops in terms of the grazing and grain harvesting. So I know Phil Alderman at Oklahoma State has looked into this a fair amount, and there's more work to be done there. All right. Dr. Kumar's question about joules and LPJ productivity modeling. How much possible feasibility between 4th and 5th plant functional types with crop productivity mapping? I'm not sure exactly what that is, but if we're talking about trait mapping, that's the kind of thing that we can do through sensitivity tests. We've talked a lot about crop, or I should say climate sensitivity tests. We haven't done as much about system and genetic sensitivity tests, which could be a very interesting way of approaching it. There is new talk about virtual crop modeling and kind of genomics crop research, especially around climate applications. So that would be very interesting to follow up on. All right, and then the other question is also from Hayden about FAO stat emissions estimates using the latest factors in the 2019 refinement. Are they calculated using tier 1 methodology for all countries? Unfortunately, I don't know the answer to that question, but I would get in touch with Francesco or Cynthia to answer that. And then let's see. And then the last question, could these crop models be used as reliable tools in managing small farms or still used for research only? So there are a number of applications where people use crop models for farm management. The challenge there is to configure the model very, very well. So it's best done when you have measurements of soil or trustworthy information about the management of the farm itself and the weather data that's driving it. But the original development of the crop models was for farm management, where people were able to kind of understand the trade-offs between different management approaches and track different levels of hazards or impacts depending on the conditions. So the basic idea of crop modeling is often to combine decisions around genetics and environment and management. And people use them both in an application and a research mode. The one thing I would just say is you have to be cautious on small farms that the level of detail in something like a climate model projection often is not good enough for a very, very fine resolution application like a single farm. So sometimes when you see a projection and it suggests that there is a yield impact for your region of a country, that is probably an estimate that represents the broader region. It doesn't necessarily represent every farm within that region. And we've actually shown that in our AgMIP regional integrated assessments, that there is often a diversity of outcomes among households, even in a region where the broader signal is increasing or decreasing. You still get people who benefit or are harmed in each situation. All right, and I see maybe, are there more questions? I see an email from Hamid. Yeah, you can send me an email. I'm happy to try to give a look to that, although it may take me an hour or two because I have to go somewhere right now. But I think with that, I've answered the questions. So thank you all for participating. And if you haven't signed up for the AgMIP listserv, that's the best way to kind of keep an eye on what we are doing. And if you have ideas for new projects or protocols, or if you are trying to do something in your own region that is consistent with the AgMIP principles, we can sometimes help provide a letter of support, not so much financial support, but at least link your project to the broader effort so that its contributions can be recognized. So I think with that, I'm going to sign off. Thank you all again, and we'll talk to you soon. Bye-bye.